Hola a todos, bienvenido a esta segunda jornada de los STEAM Days. El objetivo de estas jornadas es pues introducir un poco a los estudiantes de la Universidad Europea y a todos aquellos interesados en lo que es la realidad profesional del entorno STEAM. La Universidad Europea y la Escuela de Arquitectura, Ingeniería y Diseño, la Escuela STEAM, estamos muy ocupados, más que preocupados, estamos ocupados en introducir dentro de nuestras titulaciones la realidad profesional. Para eso tenemos distintas actividades, tenemos muchísimos contactos con empresas del sector, entre ellas las que participan aquí hoy en estas jornadas, y una de las cosas que hacemos son actividades como esta, que permiten en profesionales de primera línea del sector ofrecer la realidad profesional en el día de hoy. Esta tarde vamos a contar con distintas personas de empresas de primer nivel, como Oracle, IBM, Cloudera, o una representante de DAMA España, que es la Asociación del Dato de España, que van a ofrecernos distintas conferencias y charlas en relación con el estado, sobre todo, del dato y de la inteligencia artificial en la actualidad. La inteligencia artificial ha sido una revolución, ¿vale? Ha sido como una ola, un tsunami, no sé cómo decirlo, que nos está, pues nos está atrapando a todos. Una de las formas de surfearla adecuadamente es estar al día de los usos que se hacen en la realidad profesional y pues cómo aprovecharla convenientemente, cuándo hay que utilizarla y cuándo no. Y esperemos que estas jornadas nos sirvan un poco como receta para esta forma de actuar. Bueno, no quiero comentaros, no quiero enrollarme mucho más. Bienvenidos a todos, espero que sea interesante. Vamos a hacer dos charlas al principio. La primera que va a presentarnos Pedro Llamas. Bienvenido, Pedro. Y una segunda que va a ir de la mano de IBM. Haremos un pequeño intervalo de 10-15 minutos para continuar con las dos segundas de Cloudera y de DAMA España. Pues sin más, Pedro, bienvenido. Os presento a Pedro Llama, él es VP de Servicios en la Nube de Oracle en el sur de Europa. Es un experto y ha dado infinitas charlas y tiene muchos contenidos en Internet que son súper interesantes, os lo aconsejo. Y pues muchísimas gracias, Pedro.
Muchísimas gracias, Inmaculada. So the good part is that I'm going to be speaking in English, right? The bad part is that you're probably going to take you 2 or 3 minutes to get to the wavelength of the way that a Murciano, a person from Murcia like myself, is speaking English, which is not the way that the Madrileans speak in English, right? So I hope that you get close to my speech very, very quick, yeah? So the first comment that I have, well, first of all, is that I am not only the VP in Oracle, I'm also a professor in one of the masters in digital businesses here in the UE, right? So I feel myself at home today. So, first comment, I have used AI to do this presentation, but there is no harm to any animal as part of this. I haven't shared any personal data of myself or my students or my colleagues in the office, and I have not consumed a lot of energy because the leverage that I have done of the AI has been only to create a few pictures, okay? Now let's start. Inmaculada said that this is a tsunami, right? The revolution that the AI is bringing to our lives is making it so close to our skin that we don't even realize how much that is impacting already our lives, yeah? And the reality is that yourselves as technologists have a big responsibility, not only in the development of the new technologies that we will see today, but also on what is the leverage and how that is contributing to the improvement of ourselves as a society. I have the presentation divided in 2 parts. The first part, I'm going to be sharing some of my personal experience dealing with customers in the south of Europe who have problems today that they need to solve business problems with AI. The second part will be more directed to yourselves, more directed to students, I didn't say, but I am also a father of 2 kids of your age who are also studying STEM degrees, right? So I'm very sensitive to what that represents to yourselves, to get enabled into this technology, to go to the, to the enterprise business tomorrow. So first of all, this is a transformational technology and is reshaping the way that organizations are doing business. So the first thing that I want to show you is everyone is talking about AI. All the enterprises say that they do AI. You know the reality? The reality is this. Who has had the experience of building or assembling a furniture from IKEA? You have to do a screwdriver, you take 5 hours to do it. If you have something like this, which is electronic, you probably take 5 minutes or 1 hour. When companies say we are adopting AI, the majority of the times, they are talking about the improvement of the productivity of the employee. And that's just not enough, right? If you look at the people that I talk to every day, the CIOs, the CTOs, they are changing the way that they see the business, right? Usually these are the people who are managing the IT infrastructure in an organization, and they have to be dealing with what is going to be the next project? What's going to be this company looking like in 3 or 5 years? Forget about that. The AI is bringing the development cycles much closer, much shorter, and they are now business partners for the business organization, right? They're not just providing IT. And you will see that every employee has now a role to say into the development of the new or enablement that the new AI technologies and the way that they are impacting into the business. There is a complete shuffle, right? The type of engagement that we have now with the IT departments, with the people who is in the organization, or the big banks, or the big utilities, or the big telco providers to do business, are having now a very different type of conversation with us than the one that they had 2 years ago, even 1.5 years ago. Yeah? Why? Have you heard the term SaaScalypse? Yeah? The death of the SaaS, the death of the applications. What is an application? What is a corporate application? The people that I talk to, the CIOs of the organization, say, I have an application which is managing the customer care, right? So every time you call a call center, what is the agent leveraging to have access to your profile as a customer, where you live, which are the services that you have contracted, which are the offers that I can offer to you? And they're navigating in a menu, right? Doing some scroll down, scroll up, getting some data here, getting some data there. Some people are saying that days are over, right? And I can tell you, those days are almost over. They will be over very soon. What is the replacement of all the applications which every organization runs? Is AI. Put yourself into the shoes of a CFO. You know what is a CFO? Chief Financial Officer. Every day when he comes to the office, do you think that he wants to navigate in a menu, do a filter of the sales that happened last week? How much is coming from Madrid? How much is coming from that product? Wouldn't that be more natural that you just state in natural language what is the type of information that you want to retrieve, and the application gives that to you? What is the UI? The UI is gone. All I need is a prompt, yeah? It's a chat box where I can put into my natural language what I need from it, right? If you have a look at the way the traditional apps have been working, have you heard the term systems of record? Systems of record? Take a look at your application from the bank, the one which is running in your mobile, okay? A system of record has been traditionally a system where you are recording something that happened, and you are coming 1 day later, 1 month later, and you are reviewing what happened. I have used my credit card to buy something. 1 day later, I come and see that I have the charge in my card account, yeah? That's a system of record. You store something, you record the data, you come afterwards, and you see what happened. What is really an AI-enabled information? If you are a bank, and you have an application for your bank, and you cannot pay your mortgage this month because you spend more than you expected in your credit card, an intelligent application is able to look into what is your balance today, which are other assets that you have. For example, investment in some funds that you have invested in other type of assets in the bank, and be able to intelligently retrieve data from those assets to bring them to your bank account so you can pay your mortgage, to hipoteca, yeah, every month. Yeah? That's an intelligent application. That's not a system of record. That's the evolution of the AI into the systems. These are the type of concerns that the IT people has today, right? And it's all related to data, but not data that you store and later check. It's data that drives something that can happen without any human intervention. Those are the agents, yeah? That's the revolution of the apps. Everyone is talking about cloud today, cloud day, right? Everyone is talking about ChatGPT. Everyone is talking about, you name it, Gemini, yeah? You name it. The reality is that we are going to a world where the LLMs are going to be commoditized, yeah? You are going to be choosing and picking every LLM for every particular purpose that you require. All the organizations that I visit every day are using one of them. All of them are using more than one of them, even two, even three, for different purposes. That's not going to be making the difference today. I will tell you why. Another one. AI is driving even more differences between the different countries. Who are the countries who are investing in AI in the world? The US? How many LLMs do we have in Europe? Mistral in France? Not many more. China, DeepSeek, yeah? When I come and talk to my customers today, they say, hey, my friend, sovereignty is a problem for me. What is the sovereignty of my data? You are all experts of AI. Where are your data residing? Which are the data that you are using to train your models? Who is able to access to those data, right? How can I prevent that my data is not used to be training an LLM that I don't have access to and that doesn't belong to me? Where is the sense of ownership of my data and the leverage that we do with AI on my data? If you haven't heard the term sovereignty, you come and visit any customer of banking, any high regulated market, is going to tell you my data needs to be in Spain, needs to be in the EU. I cannot use my data to be training an external LLM. Yeah? Which are the data privacy that comes alongside it? How many of yourselves are familiar with the AI Act? Europe was the first geopolitical organization worldwide who was brave enough to get a regulation of which are the limits that prevent the ethical application of the AI. How many of yourselves know the impact of that on the sovereignty of the data? You think that you are technologists? You are probably good programmers. But the AI, good programmers, good coders, yeah? But the AI is demanding something different from yourselves. Let's look at the enterprise AI. 3 things: data, semantics, and workflows. These are mainly, those 3 topics are covering the 95% of the conversation that we have with any enterprise organization related to AI. Why data? AI has emerged with the non-structured data, yeah? The videos, the photograph, the text, which is demanding another type of storage, right? But you don't want to make that analysis in isolation with the rest of the data that you're already managing. The relational database, yeah, the structured data, that's almost the legacy, yeah? Everything now that we are talking is graphs, is JSON, different type of documents, yeah? It's about geo-reference information, and it's the vectors, right? Who on earth would be thinking that you can do proper AI if you have to be doing leverage of different sources of information for every different type of data, yeah? The LLMs are going to be providing an interface to be querying, right? And to be providing information that has been frozen at a moment in time of the training, and that you are going to be running inferencing on very generic purpose information. Is that usable in the enterprise today? No. The concept that is supplementing the value of the AI in the enterprise is the RAG. Everyone is familiar with the term RAG? Retrieval, augmented generation, all of you know what that is, right? That is the additional step that you need to do to be leveraging, right? To be leveraging the internal knowledge that only you can extract from your corporate repositories to be enhancing the response that an LLM, which is generic purpose, is going to be giving to you. You follow me, right? So the upper part is the easy one, right? We have natural language query using an LLM to do some basic questions. But the response that I get, I need to get that refined, enhanced with the information that I have in my corporate databases. And as I was telling you before, there is a very important technical challenge when you need to do AI based on sources which are of different types and which are scattered, right? Distributed across a number of different databases. That's not efficient by nature, and is one of the big conditions that the architects need to look into, right, when you are considering AI projects in the enterprise. First pillar is AI. You know another concept that is data. You know another concept which is also critically important for our customers is the fact how many of yourselves or how many of you know when was the rise of the data lakes? Data lakes were very popular like 20 years ago. We differentiate the transactional data, the one which is supporting today the business of the organization, is the one which is getting updated every second, right, in real time. The analytical repositories, the data lakes, is where we are dumping all the data coming from all the operational systems to be extracting intelligence. In the past, we were saying analytics. Today, we say AI, okay? The requirement on AI doesn't allow that to happen, right? AI happens in real time. When you have a customer on the phone and you need to provide a next best offer or a next best action to him, you cannot expect to be getting intelligence out of a transaction that you need to download into an external repository to do AI on it, right? AI on live data is a requirement. That's why the databases today, the good ones, the ones who are enabling AI, are the ones who support transactions and analytics in the same repository. These are the translytical databases, we like to say, right? Transactional and analytic in the same repository allows real-time AI. Next one. The RAG by itself is not even enough. There is a concept now which is coming across every business conversation, which is ontology or semantic, right? Pretty much they are things that represent pretty much the same. Let me put you an example of what I mean by that. In an organization, a financial department can refer to Pedro, to myself, as an account holder, because I have a bank account where I have my charges assigned, right? A customer care system might refer to me as a customer. So there is a table which is called customer. And a travel ticketing application could be referring to me as a user, right? The semantic of the term account holder, customer, or client, or user is referring to the same personality, which is me, yeah? I'm just adopting different IDs depending on how my information is stored in different repositories or in different tables, right, in different systems. The ability to drive semantics out of the schemas, right, that we have in the database, we call an ontology, right? That allows that the RAG, remember the term that I just introduced, is able to provide much more refined answers when we have a proper ontology defined in our data structure, right? What that's implied as well is that if I make a query, if I had to represent a business query, like how likely is this customer to churn, right? So to go to the competition, right? Or to stop paying for the service, there is a matter of different business queries which are interrelated that the semantics of the ontology, if I have done that properly, is going to resolve for me. For example, how many travel tickets has this customer opened in the last 2 years or in the last 2 months? Is he complaining all the time? Is he leveraging the service or using the service every month? Is he opening or complaining or it's difficult to get himself to pay every month in the bank? All those are signs that if you have a proper ontology, a proper semantic defined over your schema, is able to facilitate a lot, right? The retrieval of the data using the RAG. Okay? So, if I have a term which is called banco, banco can be an entity, financial institution, or can be a seat. Yeah? Semantic is not the same as keyword. The queries in the database based on the semantic of the term is not the same as the queries in the database based on the keywords, right? That's the difference. And that's something that avoids to have what we call the noise challenge, right? When you have an overlap of responses of terms that looks the same, yeah, but really represent very different concepts in the database, okay? The last one. There is no call that we have with customers without the term agentic on it, yeah? And if I was yourself, I would be making myself very familiar with MCP. Have you heard the MCP? Yeah? All of you have, yeah? The organization that I work for, Oracle, is an organization of 170,000 employees, yeah? It's a big ship that moving 0.5 degrees the direction of the move has taken us historically years, right? Big changes in the adoption of new standards coming in. MCP was released by Anthropic 2 Novembers ago. It was a matter of months, even weeks, that all the big players in the market adopted that as the reference model, as the standard or traditional USB, which is used to be connecting all applications, right, that needed to exchange data to be performing an AI function, right? Agentic is the ability to query one application and tell it, I want to get a flight booked versus book me a flight. There is a difference, right? The first one is not agentic, the one is agentic, yeah? There are all sorts of challenges that came up with that conversation. This is critical to the conversation that I was introducing at the beginning of the SaaS Calypso, yeah? The ability to be building and assembling capabilities on agents that have the autonomy, and the human in the loop is an important factor. Eh? Not all the business processes can be developed with agentic architecture without the human in the loop at the end of it. Yeah? This is a must conversation in every engagement as well. Yeah? So let me recap for a second. 3 pillars of every AI conversation today in the customers. Data, any type of data, leverage of LLMs. General purpose LLMs can only be valid if they are enhanced with the RAG, with the corporate repositories. That's the idea number 1. Idea number 2, the RAG is now superseded by the concept of the, not superseded, enhanced by the concept of the ontology and the business semantics of the database schema. Yeah? The third one, agentic. Those 3 pillars, I tell you, are driving the concerns and are the topics that don't let sleep the executives or organizations out there today. Yeah? So let's think if we could redefine how the work works, how we interact with the applications which are servicing the business in every organization. If you are the CFO of an organization, you want to give him the tools to be able to avoid the development cycles that offer to him the required information at every single moment of the week. We want to extract the complexity of accessing to the data and to the data enhanced with any manual human manipulation if we have an agentic application that can do that for us. Yeah? The glue that is linking all of them is the LLM. Yeah? But let me tell you something. AI in an organization is not something that you put as a, something on top of an architecture that already exists. I am a very average driver, I have to admit. Yeah? Think for a second that there would be any mean to make myself Max Verstappen, right? And I could be driving very fast for a second. Yeah? If I get into a crappy car in Madrid in the middle of a traffic jam on a Monday morning, none of that is relevant, okay? The AI infuses to all the layers of the applications or all the layers of the stack in any customer, right? From the infrastructure, and I'm going to be using the terms that you probably are very familiar with, from the infrastructure to the platform of the data, all the applications that run on top of it. It's not enough to put AI just on the application side if your data is not intelligent, right? That's what I mean. Usually the transformational project that we are seeing and we are accommodating need to be aligning the infuse of the AI across all the layers of the architecture. And that's a big challenge in certain organizations, right? Here it is. By doing that, we are able to evolve the systems of record that I was saying at the beginning, what is the systems of intelligent outcomes, which is the fair evolution of the applications, okay? It's not only to keep track of the things that happen and that you are able to consult afterwards, is to get the intelligence out of them so that the term SaaS calypso that I was introducing at the beginning now has a meaning, right, for the organizations. I will give you 2 or 3 examples. Every organization that we talk to have a department of HR. They are the ones who are scrutinizing your CVs, okay, when you are applying for a job. They are leveraging AI. And they are doing a vector of the specification of the job that you're applying to. And they are vectoring all the information, which is included in the CVs, respectively, of all of yourselves. Yeah? That's a use of the AI. There are agents that can do that job for yourself. There is a human-in-the-loop step that the head of the HR wants to have a look at before giving a job to a student who is applying for his first job. Let me give you another example. We, my colleagues who are sitting in the first row and myself, we are running at this time of the year, in the summer, we are running what we call the appraisal, which is the way that we have been performing during the year, right? The AI is able to collect the 360 feedback that other colleagues are giving to me and be producing a report for my manager on what is the performance that I have completed during the year, right? I want to be validating that. I want to be the human in the loop, certifying that that feedback is correct, okay? These are examples of agentic applications. So, what are the leaders in the industry doing? They are training themselves. They are all heavily investing in training. You have access to a lot of training from Oracle, and you can get certifications. Believe me, this is a mandatory requirement in every sales organization. I was talking this week with one of the largest firms in retail in the world. I don't need to tell you anymore. They are investing like hell. They have training for all their IT departments on AI every single week. Yeah? Second thing that they are doing, they are putting the AI is like the customer care, is like the sales attitude. It's not one department job. It's the job of everyone. It's the job of everyone because they are democratizing the AI. So in my organization, we have access to ChatGPT, to Codex. I tell you, every single person in my team, and I have more than 100 people working in my team, is leveraging the Codex and the ChatGPT in a different manner to do their job every day. And they are coming to me with ideas of adoption of AI to do my job better every day. And my job is to build presentations, is to build better demos, is to build better impactful messages when I am talking to customers because I want to sell. Yeah? AI is bringing the democracy in the adoption of the IT to the organizations. Okay? I pause for the enterprise for a second because I am now behind the schedule. So I will spread only a few words to you as students of STEM careers. Yeah? Today, the dilemmas of the coexistence is that we are very much driven by engines or by intelligence which is making decisions on our behalf, and sometimes we acknowledge that we are aware of that, and sometimes it's coming sort of transparently to our interests, and at the same time, we are the technologists who are building these applications, okay? It will be a matter of enabling every single individual from early ages into what is called the computational thinking. And that's something that probably is not being taken care of as we should in our Spanish, which is the one that I know, in our Spanish way of learning, right? What do I mean by that? How many of you are aware of the algorithmic biases that are related to the LLMs that you are leveraging every day? Do you think that a black person or a white person are equally measured in the training of the models that we are using today? There are plenty of videos in the internet which are putting a penalization of different races or the physical appearance of individuals because they don't belong to the data sets that a model has been trained on. How many of yourselves are aware of that impact? We have a colleague, a set of ladies in our organization, in Oracle, who gave to us an impressive presentation showing all the biases that all the LLMs have on the role of the lady versus the man. And how the same question is getting different answers if it is a male or it's a female. How many of yourself are aware of that ethical dilemma? Yeah? Or the opacity and the explanations. Are you aware that if a bank is using an AI to deny a help for your mortgage, yeah? They need to explain you the reasons why. The models, especially in the neural networks, when there are different layers of neural networks, are not allowing that to happen so easily, yeah? And if anyone is using AI to deny or to, provide me with a positive answer, we need to be able to explain why, which are the reasons, which are, the basis of my decision. What is the privacy? How many of yourselves have the different criteria that the EU AI Act is stating for the AI events categorization? There are 5 degrees of, how critical they are, events that affect the privacy of the individuals. If they mean sexual discrimination or race discrimination or provide subliminal messages, completely forbidden. If it is the facial recognition in real time, what is real time? Only for police, only to be detecting thefts or crime, yeah? How many of you are aware of that? How many of you know the environment where the AI is regulated into the EU? This is your duty, right? And that goes beyond the mere application of the technology. I give you more examples. Manipulations, as I say, some of the content that we are driving, I am addict to Instagram. I can spend hours scrolling into the Instagram. How many of yourselves are aware of the algorithms that drive the patterns that drive addiction in the social networks? Yeah? Synthetic truth. I have presented to you some photographs. You know that these photographs are created with AI. How much the ability to generate synthetic data is conditioning the decision that we make on our personal and professional life today. And how many of these are affecting the way that the people live and the quality of their lives. Yeah? Or the job displacement, also an important one. And I truly believe that AI is the technology with the worst marketing campaign in the history of humanity, right? All the news that you will read in the press affect to the job cuts of the AI. None of them expresses the value of the reskilling and how the augmentation of the capacities of the individual are making different jobs to come up. We have one, is another firm of the clothing, a Spanish one, who presented to us 2 years ago already the new release of the summer clothes, yeah? Beautiful ladies, very nice dresses. There was no models, there was no dresses, there was no photographer. All of that was AI. But that was being presented to the, to the internet and to the web page and to the, pictures in the street as real. Yeah? Synthetic truth. What is the ask to you? You need to be adopting a bit of the Socratic thought, yeah? You have to be able to analyze not if your software is compiling. It's about where is the data set that this software is being leveraging, right, to extract the data and the conclusion that we require. How much are you using open source structure and you are able to communicate when there is a logic dead end for your business on what is the proactivity of the logs and how you can prevent the limits of your model in a clear manner. And more importantly, if I was yourself, I would be aiming as an engineer to get the cross-pollination with the humanists, with the psychologists, with the people who take about the human reality, with the lawyers. These are the people that are going to be shaping the application of the AI and not just the technologies. That's why I like to think of the profession of the next engineer, right, the next generation of engineers, like a T. A T where the depth of the knowledge is, of course, on all the technical skills that you are acquiring during your studies, on databases, on compilers, on mathematics, on foundational hardware, and all of that. But the transversal part of the T, so the horizontal part of the T, is equally important because it's about ethics, psychology. You will hardly believe how much I have to study laws when I need to understand to a bank which are the real requirements for data residency or data sovereignty to really understand what I have to present to a bank when I have to be talking to him. And that's in the laws. That's in the regulation of the very regulated market like banking. That's not like the technologies. I was listening to one podcast the other day on YouTube was saying, anyone can build a piece of code, a machine can do a piece of code, can test your piece of code. Who is able to interpret that piece of code in the context of the business process, which is delivering a business function? That's the value of the programmer. That's the value of the technologies. Which are the core competencies? I was telling to Immaculada before we were starting the session. When I am interviewing any candidate to be joining my team, I always tell him, which are the things that you have learned by yourself without having to learn it to pass an exam? Which is the motivation that has driven that you are getting a certification on Oracle, on Google, on Amazon, whatever technology that is, that was not included in the list of signatures that you had to pass to get your certification in the UE, yeah? Which is your ability to be emotional intelligence, right? It will be looking stupid, but emotional intelligence, working in teams, speaking in public, are the things that I'm looking at when I'm interviewing technologies. Because I'm giving as granted that you know what is Java, that you know what is Python, that you are familiar with Claude, and that you can get some code to be running in a virtual machine. I am giving all of that for granted. It's the other things which makes yourself stand out, right, in an interview for a job. I have taken this note. This lady has written a book that I have read recently, which is called Inteligencia Artificial Naturalmente, Nuria Oliver. I recommend that to all of yourselves, yeah? And the way that she described that not all the technological innovation is progress is the way that I think we should be, infusing in our way to be accommodating the technology project, yeah? And to conclude, I firmly believe that AI is making the good students way, way better. The bad students and the lazy students way, way worse, yeah? And you just need to show the way that you are preparing a response to an exercise in the university and the leverage that you do of the AI tools when you are able to apply your validation of the sources, when you are able to provide or to avoid the biases into the prompting that you are using to query your LLM, into the way that you are rechecking with different toolings the type of responses that you get. this is where the real value of a good student get of AI. The lazy students is going to be putting a very quick prompt, and he's going to be taking the first answer that he gets. Yeah? In the professional life, is equally the same. I have colleagues in my team who are able to exploit the AI to do far better presentations, to qualify much better the preparation and the discovery calls that we have with customers to really understand what they are after. And others, which are just using a very poor scope of what all the AI tools provide. Yeah? The last thing that I wanted to present is perhaps room for another type of society. And I have taken this from the very famous, the Spanish people in this room will know him probably, which is Marc Vidal. You know him, right? He's very active in radio and television programs. I have been attending because he has been present in Oracle a couple of times, right, during his session. And the way that he was always concluding his sessions on AI was showing this video.
Can you grab my finger?
You know what's going to happen, right?
Are you kidding me?
Are you kidding me? So there is no machine that I think that ever is going to be able to perform this kind of humanity, right? Thank you very much, Pedro Llamas. These are my contact details on LinkedIn. So pleased to be with you today. Thank you. 39. And 39 minutes, 30 seconds left.
So thank you so much, Pedro. And now we have a round of questions. So first, yes, we have a round of questions. So first part would be on face-to-face. So if there's anyone in the room that want to make any question, raise your hand.
Don't be shy. If I don't have an answer, I have two colleagues in the first row who can answer for me.
Okay.
No?
I'm going to invite also to the people that is at the stream and that is online, you have a chat box. So if you want to make any question, please make it on the chat box. I'm going to be reading it out loud. Okay. So there's no one online, but I do have a question.
Okay.
Okay, I do have a question. So Oracle has been a company that has been on the tech market for many, many years and has been playing around in many landscapes, from solutions, from hardware, also from databases. So what is the main strategy and the main goal pursuing this AI thing, agentic AI, servers? Are they planning to compete with NVIDIA maybe?
No. No. NVIDIA is one of the key technological partners for us, right? In January last year, right after Trump got elected, 2 days later, he signed the biggest investment into deploying AI infrastructure in the US. The project was called Stargate, and it's a project worth 500 billions of US dollars. So 500,000 millions of US dollars. That is a huge data center in Abilene, in Texas, where a big portion of that is going to be related to OpenAI. So Oracle has shifted, right, a lot of the focus, and now AI is the key play for us. For the big LLMs, OpenAI leverages our infrastructure to run. NVIDIA is also training their models on our infrastructure. Meta is leveraging our infrastructure to train the models as well. So we have the best price performance architecture for training models and inferencing models out there, right? But our strategy on AI is not only on the platform layer. You remember the 3 layers that I presented? Our database is the most intelligent and the only one convergent database in the market. We have what we call the autonomous database, which is able to self-install, self-configure, self-patch, self-tune without any human intervention. And if we move one step forward, which is the application side, all our motivation now is to drive the agentic applications. We have a suite of horizontal applications that apply to any type of organization. For example, ERP. All of you know what is an ERP, right? Or human resources application, or customer care application, or marketing applications. All of them are independent on the industry. Any industry can use it. But on top of that, we have the vertical applications for different industries. For example, for telco, we have an application which is doing the provisioning of a telecommunication service. When you want to have the internet at home, you know, everything that happens between you calling a contact center and getting the fiber 1 gigabyte provision in your home, we have an application that can do that. And can do that also applying AI. If you are talking to a bank and you want to find the fraud of anti-money laundering type of crime, we have an application that leverages AI to do that. So the strategy of Oracle is now very much driven from AI, but not only from the infrastructure, right? Also from the data or platform layer, as well as other applications. And we are the unique vendor out there who can provide a role into the 3 roles, you know, into the 3 layers. Why? Amazon is very strong, number 1, right? In infrastructure and platform, they don't have business applications. Salesforce is extraordinarily strong in customer care applications and also in integration layer. They don't have a platform, right? They don't have the hardware underneath, so on and so forth. Oracle is the unique that has the 3 layers, even with the verticalization by industry.
Thank you so much, Pedro.
My pleasure. Thank you so much.
Okay. So now we're gonna give room to the second talk. So the second talk is a double talk. Okay, we're gonna be having with us Cristina Marquez and Álvaro Saavedra, and they are from IBM, another major technology vendor in the world, and they're gonna be giving 2 talks. The first talk is gonna be 100 años de historia, or 100 years of history, and the second talk is gonna be Gen AI, desafíos y oportunidades. So, Cristina, Álvaro, the floor is yours.
Thank you. Actually, the highlight is his. I'm only going to speak for a few minutes to give the intro to IBM. And as you didn't have questions, I have a question for you. What do you know? Is my presentation there? It should be, right? Okay. What do you know about IBM? Huh. You go, there is no wrong answer. It's not like some. Punch cards, yes. We started doing punch cards. What else do you know about IBM? Nothing? Have you ever used IBM's technology? Who? What have you used? Watson. Mm-hmm. Anybody else? Have you ever used IBM's technology? DB2, yes. Nobody else? Well, actually, every day you use more than 30 times IBM's technology because we are a B2B company, so all the companies or most of the companies you interact with, they use IBM's technology. They say that 90% of the times that someone pays with a credit card worldwide, they are using IBM's technology. So every time you pay with a card, you book a flight, you pay your taxes most of the times, or you buy online with one of the famous retailers, you are using IBM's technology. It's only that we don't sell technology to consumers. And what do you think about these numbers? What can it be? 100 years in Spain. So we are celebrating 100 years in Spain. Worldwide, it's been 115 years. So it's a long company. We started with punch cards. Actually, we started with machines that cut meat, but of course we have evolved, and we will tell you what we do now. We are in 170 countries worldwide. We are 270,000 employees. So if you are willing to work at IBM, you can join us in any country that you wish. Anything else? You don't know anything about IBM? Good, so I'm happy that we came. So I'm going to tell you where we come from. It's not going to be 100 years because would be very long, but I'll tell you a few things about IBM. So there is a video first. Let's see if it plays. So we need some.
For over 100 years, from typewriters to barcodes, ATMs to PCs, we helped reach the moon, and we were in the AI game before it was cool. IBM has continually reinvented itself to do what it does best, solving the biggest challenges of the day through technology. And right now, we're putting hybrid cloud and AI at the core of everything we do. Businesses face a complex technological landscape. They must modernize applications, automate workloads, guard against cyber threats, and leverage emerging technologies to stay competitive. IBM's enterprise-grade solutions helps organizations meet these challenges. But what makes us unique? We are champions of openness, infusing the greatest innovations from the community. We are pioneering responsible AI, leading governance, and partnering with other institutions to advocate AI ethics. We're helping solve some of the biggest problems facing humanity, from climate change and sustainability to development and human rights. In the future, our global network of research scientists continues to be at the cutting edge of innovation. Whether it's in semiconductors or quantum computing, we're shaping the future, one breakthrough at a time. IBM, we don't just make business work better, we make the world work better.
Okay, so this is what we do now. This is where we come from. Do you know what that is? Yeah, well, it's a hard drive, yes. But yeah, they used to be this big. Have you ever used a typing machine? You are too young, most of you, right? Well, those of us who used writing machines, I don't know if you remember that sometimes they used to flip when you, I don't know how to explain it in English, I'm sorry. But when you typed, the letters would flip with each other. And IBM patented like a new way of, it was like a ball, so it was one of the first contributions to technology 100 years ago. The barcode was invented by IBM, so every time you pay in a supermarket and you're using a barcode for paying, that's IBM's technology or contribution. The, how do you call it? The magnetic band, that's also a contribution from IBM. The first computers, the first PCs. We have been in the missions to the moon. I don't know if you have seen the movie Apollo. There were IBM colleagues working on that. Do you know this image? It was on the video as well. Who remembers what happened there? I guess you were not at that time, but yeah. And who's that? Kasparov, yeah. So we talk now about AI, but it's true that AI comes from the 50s. It's only that the computers didn't have the capacity to process what they are able to do now, but AI started many, many years ago. And this is where a computer won this chess game to Kasparov. And he was very upset, and then he developed his own software on chess. And this one, it's also very famous. There is a contest in the US, which is called Jeopardy, and the contest gives you the answer, and you have to guess the question.
And again, AI, and it was, I don't know how many years ago, Alvaro, it was, but it was like 20 years ago, I guess. This computer, Watson, or it had another, yeah, Watson, won the 2 top contestants of this show. So again, it was AI, and it was many years ago. It's only that, of course, technology has evolved in a way that now we can do many more things. Okay, this is where we come from. And can you guess what it is? The symbol? Nobel Prize. We have 5 colleagues who are Nobel Prizes. And we have 3,000 employees worldwide who work in research. Okay, and this is what we are doing now. We work mainly on hybrid cloud, on AI, and we are working on quantum. Are you familiar with quantum? That's the next hype, so I hope that you all get familiar to it. And IBM, by the way, has a lot of training on quantum if you want to take it, and it's for free. As our colleagues from Oracle, they have lots of learning offerings. We do as well, so I recommend that you use as much as you can from the companies that are sharing all these resources. And we also work on semiconductors. So that's our current strategy, and that's where we are heading towards. And we have 2 main divisions. So if you want to work at IBM, you mainly have these 2 opportunities. One of them is technology. We produce, we develop, we implement our own technology. And then we have another division, which is technology consulting. And we consult with IBM's products, but also with products from the market. So it's independent from IBM's technology. And I don't know if you're familiar with IBM Skillsville. Have you heard about it? It's the program that we offer to university students. It's completely for free. You get credentials. You get access to cloud, to IBM software. As I said, it's completely free. And we do it because we have the commitment to train 30 million people worldwide in skills on technology. And of course, it's on cybersecurity, data analytics, cloud, cybersecurity, you name it. So this is the page. You go to college students, and this is where you have the free access that I mentioned. And these are some of the courses that we have. Of course, I guess that your level is much higher, so you can also go to deeper and more sophisticated courses, but these are some examples. And we have, as I said, different layers of depth. And you can get credentials. And the good thing is that when you finish a course, you complete a course, you get a credential, and you can link it to your LinkedIn profile, which is great because when you're looking for jobs, same as Oracle, when you have an Oracle course or an IBM course, it's a great resource that you can have on your CV on top of your degree. This is the software that we give for free while you are at Universidad Europea. And if you want to work for IBM, we hire interns, we hire people who just finished their studies, and of course we hire people with experience. This is where you can check opportunities at IBM. As I said, we operate in 170 countries, so you can join us wherever you want. Of course, you always need to speak English plus the local language of the country because we work with companies that are operated locally and not everybody speaks English, but besides in Valencia, we have jobs that I will tell you now. In Valencia, we just opened, you know about it? We opened this international center. We have people from all over Europe, Africa, and Eastern Europe. So if you speak English plus any European language or Arabic or Turkish, and you want to sail, we are looking for you. This is the link to apply for the jobs. So the idea is that you join us for 12 months in Valencia. This is the side you will have from your office, and then you go back to your home country. So if you come from Turkey, you work 1 year in Valencia, you enjoy the sunny weather, beautiful site in Valencia, and then you have to go to Turkey, which I guess it's also great. And if you want to follow us, these are our social media channels, and you can also stay tuned with IBM opportunities on this link. And then I leave you with Alvaro, who is the one who is giving the masterclass. Yes. Thank you.
Hola, buenas tardes a todos. I'm going to move to Spanish, sorry. It's easier for me, I think. Voy a daros un poco una charla tecnológica, pero yo llevo 15 años trabajando en IBM, pero me he pasado trabajando en el sector bancario en funciones nada que ver con tecnología, funciones muy de negocios, de gestión de riesgos financieros, de gestión de activos, y podemos saber un poco cómo podemos aplicar esta tecnología también al mundo real en que nos encontramos, ¿no? A la actividad profesional que tenemos. Perdona. Y yo creo que estamos en un momento muy importante tecnológicamente hablando, ¿no? Siempre ha habido hitos importantes en tecnología, pero yo creo que lo importante ahora es que están convergiendo en un mismo momento tres tecnologías, tres pilares tecnológicos que han venido para quedarse, ¿no? La computación clásica, ¿no? La basada en los bits, que, oye, venimos trabajando desde las máquinas tabuladoras, ¿no? O sea, tenemos una historia muy larga en computación clásica y sigue vigente, ¿no? La computación cuántica, cuya unidad básica de medida son los qubits, y la inteligencia artificial generativa, que son las neuronas, ¿no? Aquí lo importante es que una empresa como IBM, con 100 años de historia y trabajando en máquinas tabuladoras, hoy en día se declara como que nos dedicamos a inteligencia artificial, a la computación cuántica. Es decir, estos tres pilares están presentes ahora mismo en nuestro propio ADN, ¿no? Y cuando hablamos de computación clásica, pues esto un chip, todos vosotros lo conocéis, ¿no? Somos muy familiarizados. Pero tenéis que pensar que esto es un ordenador de los años 50 que pesaba 30 toneladas. Es decir, hemos pasado a que hoy en día hay un transistor con una longitud de puerta de un átomo de espesor. Imaginaros. ¿Y esto por qué ha sido posible? Pues fijaros, porque durante casi 50 años, bueno, durante 50 años, de los 70 al 2020, se ha cumplido la ley de Moore, ¿no? Que lo que venía a decir es que el número de transistores en un microchip se doblaba cada 2 años. Y si cogéis aquí la gráfica del 70 al 2020, pues veis que es casi una línea recta, se cumple a rajatabla, ¿no? Hoy en día, pues es que en el espacio de una uña tenemos 50 billones de transistores. IBM tiene chips de 2 nanómetros. Claro, para el que no le diga mucho la unidad de medida, el espesor de un pelo de cabello son 100.000 nanómetros. A mí cuando me lo dijeron, pues realmente es algo que impresiona, ¿no? Y fijaros, tenemos un reto siguiente, que es llegar a 1 nanómetro, ¿no? Pero estamos en un momento en que ya existe una limitación física. Realmente está pasando y existe que con estos espesores ya los electrones se escapan. Yo utilizo muchas analogías para contar las cosas, ¿no? Y esto viene a ser como un grifo que gotea. Pues estamos en esta situación. Y aunque estamos trabajando en nuevos componentes, estamos trabajando en nuevos materiales, se está trabajando también en nuevas formas ópticas de comunicarse entre los transistores, realmente esta limitación existe. Y es lo que hace que la ley de Moore desde el año 2022 más o menos no se está cumpliendo y que sabemos que ya no se va a cumplir nunca en la misma proporción. Y es en este contexto donde nace la computación cuántica, ¿no? Y hablamos de los qubits. Y claro, la computación cuántica se basa, como su nombre indica, en la física cuántica. Yo no soy físico cuántico y en esta charla intentar explicar algún concepto de superposición, entrelazamiento, pues es realmente complicado. Pero al menos sí que me gustaría que os quedara, por lo menos a alto nivel, una idea de la diferencia entre la computación clásica y la computación cuántica. Y os voy a intentar poner un ejemplo. La computación clásica, como sabéis, se basa en bits. Los bits son valores binarios, tomar valores 0 y 1. Con 0 y 1 represento toda la realidad. Si yo cogiera una moneda, la podría decir que ese es un bit, ¿no? Donde la cara es el 0 y la cruz es el 1. ¿No? Podría coger esto. Si yo esa misma moneda la lanzo al aire, y aquí tenéis que hacer un ejercicio de abstracción mental, mientras está en el aire, esa moneda indistintamente vale cara y cruz, vale indistintamente 0 y 1. Pues eso es un qubit. Entonces, esto tiene importancia para la hora de resolver problemas, porque si yo os dijera, siguiendo con el ejemplo de las monedas, representar los valores del 0 al 3 utilizando monedas, ¿no? Pues podría coger 2 monedas, decir, cara a cara es igual a 0, cara a cruz es igual a 1, cruz cara es igual a 2, cruz cruz es igual a 3. Es decir, con 8 monedas en computación clásica habría solucionado, representado los valores del 0 al 3, ¿no? Si lo hago en computación cuántica, sería como si cojo 2 monedas, las lanzo simultáneamente al aire, y como os decía, mientras están en el aire, valen 0 y 1, valen cara y cruz, pues es lógico pensar que con 2 monedas voy a poder representar todos los valores del 0 al 3, ¿vale? Si me voy y en vez del 0 al 3 os dijera que quiero representar los valores del 0 a 1 billón, pues fijaros, si lo hago con computación clásica, y eso si tenéis ganas en vuestras casas de hacerlo, pues necesitaría 40 billones de monedas, ¿vale? Con computación cuántica, y ahí tenéis que confiar en mí, tenéis que creer en mi palabra, necesitaremos solo 43. Es decir, hemos simplificado el problema de forma muy importante. Y esto es un ejemplo de un ordenador cuántico. Yo creo que tenemos el orgullo en España de que hay los dos ordenadores cuánticos más potentes del mundo. Uno está en Estados Unidos y otro lo tenemos aquí, en España. Además, lo están utilizando para las empresas, en el Centro de Computación Cuántica de Euskadi. Para los que nunca habéis visto un ordenador cuántico, pues tiene esto, le llaman el candelabro, ¿no? Por razones un poco obvias. El chip cuántico está aquí en la parte de abajo y solamente trasladaros. Son ordenadores muy sensibles a cualquier elemento exterior. Tienen que estar en temperaturas de frío absoluto, en temperaturas del frío del espacio exterior, ¿no? A menos no sé cuántos grados Kelvin, ¿no? Y lo importante aquí es que todas estas conducciones que veis unas conducciones verticales, lo que hacen es inyectar helio, que lo que permite es disipar el calor, y estas conducciones que veis ahí no se ven muy bien, pero son como circulares, ¿no? Pues hacen ese efecto electromagnético que os decía en la analogía, ¿no? De que permitir como que las monedas floten, ¿no? Bueno, lo he comentado, es el más potente, lo tenemos. ¿Y por qué es importante la computación cuántica? Miráis, ¿por qué complementa a la computación clásica? Porque nos va a permitir resolver problemas que la computación clásica sabemos que no va a ser capaz de resolver. Y esto es lo verdaderamente importante. Os pongo un ejemplo. A principios del siglo XX se produjo en Europa una hambruna muy importante. O sea, la producción agrícola era incapaz de atender las necesidades de alimentación de la población europea. El crecimiento de la población europea era mayor. Ante esto, pues las grandes potencias europeas se pusieron a investigar, ¿no? Y en concreto hubo dos investigadores alemanes, Fritz Haber y Karl Bosch, que descubrieron un proceso, que además tiene su nombre, el proceso de Haber and Bosch, vamos, sus apellidos, mejor dicho, por el cual se producía el amoníaco, que el amoníaco es la base de nuestros fertilizantes, ¿vale? También es la base de explosivos, pero eso es otra historia, ¿no? Entonces, este proceso solucionó el problema y de hecho es un proceso que se sigue utilizando en nuestros días. Es el mismo proceso que se sigue utilizando en nuestros días. ¿Cuál es el problema? Que es un proceso altamente demandante de energía. Se estima que el 10% de la energía mundial lo consume este proceso de Haber and Bosch. Y además deja una huella de carbono bastante considerable, ¿no? Entonces se descubrió posteriormente que existía una molécula en la naturaleza que se llama nitrogenasa y que tiene la estructura química, ¿no? Que veis ahí, bastante compleja, ¿no? Que hacía lo mismo o parecido al proceso de Haber and Bosch, pero de una forma más rápida y más eficiente. De tal manera que todo el mundo dijo, bueno, pues si somos capaces de reproducir sintéticamente esta molécula y de producirla a escala industrial, pues imaginaros el impacto que tenemos sobre la economía y sobre la sociedad, ¿no? Y aquí es donde surge el problema de representar las moléculas, porque representar las moléculas con computación clásica es complejo. A ver, simular una molécula como el agua, pues son 1000 bits, ¿no? Que es sencillo, ¿no? O acetato, estamos hablando de 10 a la 9 bits, que sería el equivalente a lo mejor a una película de alta definición, ¿no? Pero cuando hablamos de una molécula que tomamos pues, casi todos al levantarnos para despertar, ¿no? Como la cafeína, pues estamos hablando de 10 a la 48 bits, es decir, 10 y 48 ceros. A mí son cifras que me cuesta procesar, ¿no? En mi cabeza. Y si hablamos de una molécula de la penicilina, hablamos de 10 a la 80 bits, que son todos los átomos del universo. No vamos a resolver este problema con computación clásica, claramente. Con computación cuántica, pues en qubits lógicos, y luego explico rápidamente también la diferencia entre qubit físico y lógico, pues estamos hablando de 1500 qubits, 440 qubits lógicos. Todavía estamos lejos. Realmente no podemos, con la potencia cuántica que tenemos en los ordenadores de hoy en día, no podemos representar todavía la cafeína ni la penicilina, pero estamos en vías, estamos mucho más cerca de conseguirlos. Este es el roadmap de IBM de computación cuántica, que es un roadmap público, lo podéis consultar, y además es un roadmap que lleva ya hace tiempo y se va cumpliendo a rajatabla. Se cumple a rajatabla porque no solo por nuestros clientes, sino porque los inversores ponen mucho cuidado en vigilar que este roadmap lo cumplimos. Y nos penalizarían mucho si dejamos de cumplirlo, con lo cual ponen muchísimo foco. El System 2, que es el más avanzado, que es el que tenemos en San Sebastián, tiene 1000 qubits físicos, que os decía, la diferencia entre qubit físico y qubit lógico. Os decía, los sistemas son extremadamente sensibles a esas condiciones exteriores. Los qubits se deterioran. Entonces, a día de hoy, los qubits físicos no todos se pueden utilizar. Solo los que podemos realmente utilizar son los qubits lógicos, que son los que utilizamos para los casos de uso reales. Para que os hagáis una idea de la equivalencia, y depende del fabricante del hardware, del software, 1000 qubits físicos podrían estar entre 30, 70, 80 qubits lógicos, depende, ¿vale? Pero para que tengáis una idea. En 2029 ya vamos con el Sterling a tener 200 qubits lógicos y con el BlueJay en el 2033 2000 qubits lógicos que ya nos permitirían resolver problemas de cierta envergadura, ¿no? Hitos importantes que tenéis que tener en computación cuántica. Este año era muy importante, o es muy importante, porque es el primer año que anunciamos la ventaja cuántica. ¿Y qué es la ventaja cuántica? Que por primera vez, en casos de usos reales, en producción, íbamos a tener ordenadores cuánticos con algoritmia cuántica trabajando mejor o produciendo un mejor resultado que lo que haría un ordenador clásico. Eso IBM me lo ha demostrado, luego os pondré un ejemplo, ¿vale? de un caso de uso que tenemos en un banco. 2029, tolerancia a fallos. Es decir, donde por primera vez esos qubits que os decía, se va a minimizar la probabilidad de que tengan errores. Si os fijabais en el Quantum Sterling en el 2029, ya solo hablábamos de qubits lógicos, no hablábamos de qubits físicos. Y hay un tercerito que no he puesto, que es el de amenaza cuántica. Y no lo he puesto porque no hay consenso todavía claro en la fecha, ¿no? Hay gente que dice 2029, hay gente que se lo lleva a 2030, todavía no existe tanto consenso, ¿no? Pero me parece importante que lo conozcáis. Igual que existe una ventaja cuántica, existe una amenaza cuántica. ¿Por qué? Porque todos nuestros sistemas de criptografía, de claves, para que nos entendamos, están basados en un protocolo que es RSA. Para no alargar mucho, se basan en que al final multiplicar dos números primos, por grandes que sean, con un computador clásico, es sencillo, lo puede hacer bastante sencillo. Sin embargo, si lo que queremos es ese número factorizarlo en los componentes P por Q, eso en un computador clásico tarda años, no lo puede llevar a cabo. Sin embargo, en los algoritmos cuánticos existe un algoritmo, que es el algoritmo de Short, que en pequeña escala ya es capaz de resolver este problema. De tal manera que cuando tenga la potencia, cuando tengamos los qubits necesarios, pues pondría en riesgo todas nuestras claves. Fijaros la importancia que esto tiene para los gobiernos, las empresas, etcétera. Se lleva tiempo trabajando en esto, se está trabajando en algoritmos quantum safe, ¿no? Hay un organismo en Estados Unidos, el NIST, el National Institute of Standards Technology, que valida, no certifica, valida estos algoritmos. Creo que había, no sé exactamente, creo que había 5 ahora mismo ya validados. Y bueno, pues el orgullo también es que 3 de ellos están hechos por investigadores asociados a IBM, ¿no? 2 componentes en computación cuántica. El chip cuántico, que os decía, a día de hoy tiene errores, ¿vale? Parecido a los chips de silicio, que conocéis. Y los algoritmos cuánticos. Los algoritmos cuánticos, algoritmos matemáticos, ha habido en toda la historia de la humanidad. Y llevamos trabajando con algoritmia matemática toda la vida, ¿no? El primer algoritmo creo que es del siglo 300 a.C., el algoritmo de Euclides, ¿no? Los algoritmos cuánticos no, son recientes, llevamos 20, 30 años, muy poco tiempo en relación con los algoritmos matemáticos. ¿Y esto qué significa? Pues que al final todavía podemos aumentar muchísimo la precisión, ¿no? Podemos hacerlos muchísimo más precisos. Por estas 2 razones es por las que yo os decía, si veis el título de mi presentación, que la computación cuántica es probabilística, no es determinista, hay un error, ¿vale? Y por lo tanto, eso lo tenemos que tener en cuenta cuando trabajamos en las empresas, en los casos de uso. Os decía, el ejemplo de ventaja cuántica en IBM ha sido con HSBC, es un banco internacional con sede en Reino Unido, donde hizo un caso de algoritmo de trading de bonos que puso en producción. Esto tiene mucha importancia porque, fijaros, cuando se hizo el anuncio de este caso de uso, la acción de HSBC subió muchísimo y la acción de IBM subió muchísimo. De hecho, si os habéis fijado, justo ayer se ha anunciado que el gobierno americano va a hacer una inversión conjunta con IBM, va a poner 1.000 millones y nosotros otros 1.000 millones en un chip cuántico. Fijaros que ayer, en cuanto se hizo el anuncio, la acción de IBM subió cerca de un 10 o un 12%. ¿Por qué? Porque el mercado está muy expectante qué va a pasar con la computación cuántica y qué va a pasar con la combinación de estas tecnologías que os decía, porque genera ventajas competitivas reales en las empresas y en las sociedades. El mundo de las neuronas, de la inteligencia artificial generativa. Yo os pregunto, ¿a quién os suena WatsonX? ¿Os suena alguno? Bueno, a Manuel sí que ha dicho que evidentemente por razones obvias, pero ¿a alguno suena? Levantad la mano a ver si hay alguno. ¿Nadie? Bueno. A ver, me preocupa que no suene, pero no hasta cierto punto. Y digo hasta cierto punto porque si os dijera ChatGPT o os dijera Google Gemini, me levantaréis toda la mano, ¿vale? Entonces, ¿por qué? Porque esa es inteligencia artificial que está dirigida a consumidor final. IBM no dirige esto a consumidor final, lo dirige al mundo de empresas. Y realmente las reglas de juego de las empresas, y lo comentaba también el anterior ponente, no son las mismas. Son reglas de juego diferentes. Necesitas gobierno, necesitas seguridad, necesitas trazabilidad, necesitas cosas diferentes, ¿no? Por lo tanto, pues hasta cierto punto es normal. Para si alguien nos pregunta, porque a veces me preguntan qué es Watson X, Watson no tiene nada que ver con el detective, con el investigador, ¿vale? Es el apellido del primer presidente de IBM, Thomas Watson Sr., y la X se añadió cuando introdujimos la inteligencia artificial generativa por el concepto de que queríamos escalar la inteligencia artificial dentro de las empresas, por el concepto de que queríamos ser abiertos y que un poco no queremos ser un modelo black box. Queremos dar esa trazabilidad porque, por otra parte, en el mundo empresarial al que nos dirigimos nos lo exige, ¿no? Y a la inteligencia artificial generativa no llegamos de sopetón. Y también lo comentaba mi compañera Cristina. Es fruto de un recorrido. Y, por cierto, y esto es, yo hablo muchas veces, yo trabajo con clientes y les digo, oye, al final, no todo tiene que ser inteligencia artificial generativa. Los distintos tipos de inteligencia artificial son muy válidos según el caso de uso que queráis hacer. Por ejemplo, los sistemas expertos de los 50, sistemas computacionales basados en reglas. Pues si yo hoy en día quiero hacer, imaginaros, un libro de recetas interactivo y yo voy a preguntar por los ingredientes y tengo estos ingredientes, ¿qué recetas puedo hacer? Pues me va a devolver una respuesta muy válida, muy determinista porque he cerrado pero muy válida. No se va a inventar, no me va a crear una receta, pero si es lo que busco, me va a responder muy bien. En los 80 sale el Machine Learning, ¿no? Y el Machine Learning, yo como os decía, me gusta utilizar las analogías, pues es como vosotros, ¿no? Sistemas de aprendizaje automáticos basados en datos, ¿no? Cuando más datos, más precisión, y es como cuando estudiáis para un examen, ¿no? Y os vais estudiando los ejercicios de exámenes históricos, ¿no? Y cuanto más ya hacéis, cuando llegáis al examen, pues estáis mejor preparados para resolverlo, tenéis más probabilidad de hacerlo bien, ¿no? Lo ha comentado mi compañera, nosotros lo que hacemos es que todas estas tecnologías, cuando salían, las poníamos a prueba en una competición. Era una manera de probar que la tecnología estaba madura. Y esto fue cuando ganamos al campeón del mundo de ajedrez. Y lo hicimos así. El Deep Learning, pues el sistema de aprendizaje automático de varias capas. Hay el concepto de Deep, ¿no? Que conocéis, que intenta replicar la estructura del cerebro humano. Importante aquí, ¿en qué se diferencia del Machine Learning? En la forma de aprender. Si yo le estoy enseñando a que reconozca imágenes, en el Machine Learning le tengo que dar alguna pista. Si estoy, por ejemplo, para que reconozca la imagen de un gato, le tengo que decir, oye, fíjate en las orejas. Con el Deep Learning, no. Con el Deep Learning, él es capaz de captar pues, el rostro, la granularidad, es capaz de tener en cuenta todo eso. Es más parecido a cómo aprendemos los seres humanos, como aprendemos los niños. Nos das distintas imágenes, 3 o 4 imágenes, y cada cuarta es capaz de asociarte, oye, esto es un gato, se corresponde a un gato, ¿no? El Machine Learning lo utilizáis a día de hoy cuando utilizáis el Netflix, ¿vale? Por ejemplo, es la tecnología que está presente en el Netflix, para que tengamos. El Deep Learning lo tenéis presente en todos los sistemas de reconocimiento facial, lo que hay por detrás de Deep Learning, ¿vale? Y por último, la IA generativa, ¿no? Y la IA generativa ha dado una masterclass antes el otro ponente. Yo aquí quiero dar 2 conceptos que sí que me parecen importantes. Uno, los LLMs. Habéis hablado mucho de LLMs y lo ha comentado también. Nosotros vamos al mundo empresarial. Los grandes LLMs están entrenados con toda la información y con todos los datos de Internet. Y eso tiene implicaciones muy importantes, muy importantes. Y para el mundo empresarial, por otra parte, tampoco lo necesito. Yo no necesito que vaya a hablar de filosofía. No es la realidad, no lo necesito. Entonces nosotros apostamos por LLMs más pequeños, por poder trabajar con LLMs propios, pero también de terceros en un mundo abierto, por LLMs que se puedan entrenar también con datos de la propia empresa y customizar con datos de la propia empresa, por supuesto con seguridad, con privacidad, con gobierno, con trazabilidad, con control de sesgos, todo lo que hemos hablado o que os han comentado antes, pero optamos por esa vía. Y luego otra cosa que a mí me preocupa muchas veces cuando, no con estudiantes, sino cuando me dirijo en general a la gente a hablar de la inteligencia artificial, es que hemos asociado mucho la inteligencia artificial a los asistentes de lenguaje natural, a los chatbots. Es decir, yo a mis hijos son más pequeños, pero no, esto es no. Realmente los LLM son modelos del lenguaje. El lenguaje no es solo el lenguaje natural. La química, estaréis conmigo, que es un lenguaje, y un lenguaje muy importante, ¿no? Los lenguajes de programación, COBOL, Python, todos los que hay, son lenguajes. La música, las imágenes no dejan de ser formas de representación y también lenguajes. Y por lo tanto, nosotros, ejemplos, oye, trabajamos con empresas cosméticas en el desarrollo de cosméticos sostenibles, con empresas farmacéuticas en el desarrollo de nuevos componentes, de nuevos fármacos. Con la NASA hemos hecho un acuerdo de colaboración de utilizar las imágenes de los satélites para hacer modelos que intenten prevenir catástrofes naturales. Pues ese es un ejemplo. Por lo tanto, todo este rollo, ¿para qué? Porque hay 3 pilares tecnológicos y os vais a tener que enfrentar a cómo resolvemos en un caso real en las empresas cuando vamos los problemas, ¿no? Y esto es muy famoso, ¿no? Es el caso del laberinto. Esto se puede solucionar realmente con las 3 tecnologías. Lo podrías solucionar con computación clásica. Hay un método que te dice que pintando cada pared de un color consigues llegar a la salida del laberinto. Con computación cuántica yo podría poner a una persona a recorrer el laberinto, cada vez que llega a una intersección se clona y así sucesivamente, ¿no? Entonces habría un clon que llegaría a la salida y además lo haría de forma muy rápida, ¿no? O con inteligencia artificial, que sería que pondría más o menos a todas las personas, a una serie de personas a recorrer el laberinto y luego basado en su experiencia, basado en su feedback, pues podría salir del laberinto o, mejor dicho, tendría más probabilidad de salir del laberinto, porque no deja de ser probabilístico, ¿no? Al final, no lo he dicho, pero la inteligencia artificial generativa, lo contaba también el anterior ponente, se basa en que soy capaz de predecir la siguiente palabra, la siguiente token en base a unos vectores. Palabra es el token, ¿no? Es el trozo de palabra, pero al final es probabilístico también claramente, ¿no? Entonces, claro, cuando nosotros vamos a las empresas, a mí me interesa mucho entender el riesgo. Yo vengo de riesgos financieros, pero es que el riesgo lo medimos también aquí en tecnología, en los casos de uso. ¿Cuál es el riesgo? Mi caso de uso es de alto riesgo, me voy a flujos deterministas. Mi caso de uso es de bajo riesgo, me voy a flujos probabilísticos o generativos. Y en el medio una combinación de ambos de todo lo que quiera. ¿Por qué? Os pongo un ejemplo también muy rápido. Si yo estoy haciendo un agente para reservarme el viaje de trabajo y se equivoca y me coge un hotel un día que no es mi preferido, pues hombre, me molestará, pero no va a ser un gran drama, ¿no? Si se equivoca y me recomienda un producto financiero que no corresponde a mi perfil, pues me estoy cargando una normativa BiFID, voy a tener un riesgo regulatorio, voy a tener un riesgo reputacional del cliente. Entonces, no me lo puedo permitir. Entre medias, pues hay combinaciones de todos los casos. Y aquí es donde surge, y también un poco se ha comentado antes, la necesidad de orquestar los agentes. Hay un informe que dice que los pilotos de inteligencia artificial generativa es brutal. El 95% de los pilotos que se hacen no se pasan a producción, no llegan a producción a las empresas. Hay muchas causas, no es la única, pero una de ellas es que las empresas han trabajado habitualmente con sistemas deterministas, con sistemas claramente preparados de esta manera. Es difícil integrarlos con sistemas probabilísticos, es difícil integrar los agentes que vamos creando, que además van surgiendo como setas en la organización, orquestarlos entre sí y además integrarlos con las aplicaciones y los sistemas existentes que tengo en mi empresa. Nosotros aquí sí tenemos una propuesta bastante única, que es el Watson Orchestrate, que hemos lanzado no hace mucho, que pretende orquestar eso, agentes propios y de terceros y con las aplicaciones existentes o los sistemas existentes de la empresa. Por último, y le hemos hablado, lo comentaban también antes un poco, a mí me preguntan mucho, y eso es una pregunta bastante recurrente, si vamos a tener una inteligencia artificial generativa como la humana, ¿no? Yo, mi opinión, y esto es opinión personal, ¿no? Es que no, ¿vale? Ni en el medio ni en el largo plazo. ¿Por qué? Porque efectivamente hay cualidades humanas, se esperaba muy bien en el vídeo, pero es que no las podemos, el pensamiento crítico, la capacidad de colaborar con los demás, la capacidad de liderazgo, la empatía o la inteligencia emocional, es que son todo cualidades que no se pueden replicar. No sé si habéis visto la película Interestelar, si no la habéis visto os la recomiendo, está chula, pero habla precisamente un poco de esto. Es decir, oye, ahí se están jugando el futuro de la humanidad. Nosotros en las empresas nos jugamos una negociación o nos jugamos ese tipo de cosas. Pero es verdad que no se puede replicar, que es muy complicado. Y aquí hay gente que me pregunta también en las charlas, ¿no? Cuando damos. Y entonces, la inteligencia artificial generativa crea, ¿no? Pero puede crear, ¿no? Bueno, crea a partir de millones de datos, combinaciones, etcétera, pero no crea de cero. ¿Y sabes por qué no crea de cero? Porque no puede soñar. Eso es propio humano. Entonces, bueno, yo creo que eso es un matiz importante. Esta frase me gusta mucho porque es de un doctor en Oxford, creo que es biólogo historiador, que dice que nosotros no prevalecimos como especie por ser más inteligentes que los animales, sino por nuestra capacidad de cooperar mejor. Y yo creo que eso IBM lo tiene muy en el ADN y es una de las cosas que a mí me gusta, por ejemplo, mucho de la empresa en la que trabajo. La investigación, el mundo de investigación, el mundo del quantum. Tenemos redes abiertas con universidades, con estudiantes, con gobiernos. Es la única manera realmente como que podemos avanzar en investigación si sabemos cooperar entre nosotros. Y yo creo que incluso el ecosistemas, incluso entre empresas tecnológicas, cada vez esa cooperación es mayor, es sorprendentemente mayor, ¿no? Y a mucha gente le sorprende, ¿no? Es que es la única manera de avanzar todos, ¿no? Y por último, y vosotros lo tenéis en vuestro ADN, pero seguramente con otra gente que tengo charlas no es siempre, vivimos en un mundo totalmente dependiente de la tecnología. Dependemos de tecnología profesional, personalmente, etcétera. Y tenemos que entender lo que hay detrás de esa ciencia y de esa tecnología. Tenemos que aprender a entenderlo porque es la única manera de que mejoremos la productividad de nuestras empresas y de que seamos capaces de avanzar como sociedad también. Entonces, no se trata de usar la inteligencia artificial, como yo les digo a mis hijos, por ejemplo, sino de utilizar la inteligencia artificial o a la gente que trabaja en mis equipos. Utilizar la inteligencia artificial es sacar provecho en productividad, es delegar tareas, pero manteniendo tú el control, sabiendo lo que quieres tú buscar al final. Y bueno, esto era un poco lo que os quería contar y espero que os haya resultado de interés.
Muchas gracias, Chris. Muchas gracias, Álvaro. Una charla muy fascinante. Abrimos el turno de preguntas. No sé si alguien en la sala quiere hacer alguna pregunta a alguno de los dos. Does anyone in the room wants to make any question to any one of the speakers? Dani.
Hola.
Espera. Si no, no soy online.
Hola, buenas. Muchas gracias por la charla hoy. Yo tenía una pregunta también más relacionada a lo que tú estabas contando sobre que los modelos de lenguaje grandes como ChatGPT, Claude y eso están entrenados en extremadamente todos los tópicos del mundo porque están hechos para ser accesibles a todo el mundo. ¿Tú crees que más del futuro en términos de cómo integrar los modelos de, digamos, generación, o sea, generative AI, dentro de las compañías va a ser más buscando integrar los modelos más pequeños, los small language models? Yo sé que IBM tiene un modelo que creo que es como 4 billones de parámetros y parámetros, y también hay otros que, por ejemplo, Apple y Google y Microsoft están usando. ¿Usted cree que eso es más por donde deberían pasar las compañías para ser más específico y no gastar tanto en torno a los costos de los modelos de lenguaje?
Es muy buena pregunta, ¿vale? Yo, efectivamente, aquí dos puntos importantes. Lo que te decía, nosotros como IBM nos dirigimos a un mundo de empresa. En ese mundo de empresa creemos que modelos más pequeños, y apostamos por eso, de hecho es nuestra estrategia, modelos más pequeños se comportan mejor, son más precisos y sobre todo mucho más eficientes en costes que utilizar un modelo grande. Modelos más pequeños que además, como decía un poco en mi charla, puede incluso customizar con datos de la propia empresa, porque hay veces que hay datos muy importantes en las empresas que tengo que ser capaz de incorporar en esos modelos, garantizando que además no puedan ser utilizados por terceros. Entonces nosotros, efectivamente, es muy buena pregunta, apostamos por eso, modelos grandes, un LLM es grandes, large, ¿no? Pero más pequeños. Tenemos una gama de modelos que es propia nuestra, que son los modelos Granite, ¿vale? Que son los nuestros, pero de nuevo, esto ha cambiado mucho y trabajamos con modelos de terceros, trabajamos con llamas, trabajamos con modelos de hecho, de casi todo, hay una lista que se ha ido ampliando y hay un montón de modelos. Y cogemos siempre, fijaros, el modelo más adecuado al caso de uso que estamos intentando trabajar. Para clientes no siempre no siempre, muy pocas veces a lo mejor utilizamos el modelo Granite, utilizamos un llama o utilizamos porque consideramos que es más adecuado para ese caso de uso, ¿vale? Entonces, en tu opinión, estrategia de IBM, por lo menos de mi compañía, no puedo hablar, evidentemente, del que se dirija al consumidor final, pues seguramente tenga más sentido un gran modelo, ¿no? Nosotros, entre estrategia empresarial, modelos más pequeños y un mundo abierto. Y modelos también que se puedan customizar con datos de la propia empresa con seguridad.
Gracias.
No sé si te he respondido.
¿Alguien más?
Buenas tardes. Bueno, en
Hola,
primer lugar,
tardes.
Gracias por la presentación.
A vosotros.
Un poco en la línea de lo que has comentado, de que el 95% de los modelos que se desarrollan internamente en la empresa no salen a producción. A mí siempre me ha dado la sensación que hay un gap muy grande entre el estado del arte de una tecnología y la adopción real que da esta tecnología en la empresa. Pero sí es cierto que con estas nuevas tecnologías de inteligencia artificial y generativa se está hablando mucho, están teniendo mucha publicidad. ¿Crees que muchas empresas se están acelerando y están acortando este gap con respecto a estas tecnologías, o estamos viendo una evolución parecida a la que hay con el gap tecnológico que hay en otras tecnologías? anteriores.
A ver, yo te doy mi opinión personal, ¿vale? Lo que yo veo, por ejemplo, es todo el mundo está muy interesado en sacar casos de uso de inteligencia artificial. Más que casos de uso, ahora agentes, ¿no? Todo el mundo está sacando agentes de automatización de inteligencia artificial. Eso, primero hay que evaluar si en todo necesito un agente o necesito otro tipo de tecnología, ¿vale? Supongamos que trabajamos aún así en esa línea de trabajar agentes. Se está trabajando de manera desordenada, es decir, lo que se está haciendo en muchas entidades y en muchos es te doy acceso a Copilot, a no sé qué, piensa qué vas a hacer con él, luego te voy a crear un agente para hacer no sé qué. No se está trabajando de una manera ordenada y están saliendo un gran número de agentes, por ejemplo, en donde yo llevo la relación directa con BBVA, ¿vale? Que es un cliente estratégico para nosotros. Bueno, pues está trabajando y está muy metido en inteligencia artificial generativa. Es un banco muy maduro en inteligencia artificial generativa. Pero hay que orquestar todo eso. Y eso tiene que convivir con sistemas computacionales tradicionales. El mainframe que es de IBM, es en los ordenadores clásicos, que al final es lo que abren todos los días el banco. Tienen que convivir con aplicaciones y con sistemas existentes e integrar eso no es sencillo. No es sencillo porque piensa además lo que os decía, que la inteligencia artificial generativa no te va a dar nunca la misma respuesta. Nunca. Y te vas a integrar con un sistema que sí que te pida una respuesta única. Y por cierto, cuando hablábamos del caso de scoring de crédito, pues claro, el caso de scoring de crédito, pues yo puedo utilizar, por supuesto que puedo utilizar la inteligencia artificial generativa, que puede investigarme a mí en redes sociales y puede hacer un montón de cosas, pero hay sesgos. Y a un supervisor que va a vigilar si esos sesgos no. Y por cierto, le voy a tener que explicar por qué toma esa decisión de crédito. Entonces, eso luego en la práctica no es fácil de llevarlo a cabo. Estoy poniéndote un ejemplo un poco. Entonces, no es tanto de la tecnología es que esté madura, está madura. Yo creo que ahora mismo la tecnología está madura, pero hay que trabajar en cómo aplica esa tecnología a los casos de uso. Y el mundo de la empresa no es el mundo del consumidor final. No es el mundo de yo pregunto aquí, me devuelve, bueno, se ha equivocado, bueno, ya sé, no es un mundo, por eso es necesario hacer ese análisis. Yo creo que por eso es por lo que pasa, bueno, hay muchas razones, pero por eso era un informe que además no era de IBM, pero decía eso, oye, al final no se lleva a cabo. Y luego el otro problema es lo que os decía antes, hay muchísimos agentes ahora, están surgiendo, que los tengo que orquestar, los tengo que gobernar, tengo que gobernarlo con las aplicaciones y con los sistemas existentes que ya tengo en la empresa, y eso es el otro reto que hay ahora mismo, en mi opinión, vamos. Pero es una muy buena pregunta. ¿Sí? Sin micrófono te escucho también.
Bueno, muchísimas gracias por la charla. Yo, aunque sea hoy el día de Data Night Day, creo que te voy a hacer una pregunta por lo de Quantum Computing que también es súper interesante. Y es que, bueno, te voy a hacer la pregunta del millón. ¿En qué momento estamos del desarrollo de esa tecnología? ¿Y cómo tenemos que prepararnos para hacer frente a ella?
Pues mira, muy buena pregunta. Desarrollo de la tecnología. Estamos en un momento que os decía, este año era clave, ¿vale? Este año era clave porque por primera vez se decía que iba a haber ventaja cuántica, lo que os decía antes. Es decir, que iba a haber un caso que realmente iba a dar valor. Estamos avanzando a marchas forzadas, ¿vale? Cuando digo marchas forzadas, muy, muy rápido. Porque para determinados casos de uso es crucial conseguir esa ventaja competitiva. Por ejemplo, el trading de bonos, la valoración de riesgos financieros en banca, ¿no? Yo vengo mucho del mundo de banca. Son casos de uso que a día de hoy se calculan con proxies, ¿vale? Con aproximaciones. Yo calculo un value at risk, un valor en riesgo de una cartera de valores, cuál es el riesgo de mi cartera, y lo hago con un escenario de Monte Carlo que al final, pues depende del número de simulaciones, no deja de tener un error. Con la computación cuántica, si yo desarrollo un algoritmo, voy a apreciar mejor el riesgo. Y ya hay algoritmos que se están desarrollando. Esos son todos los algoritmos que os decía, que se están trabajando en ellos y que ya se están desarrollando cada vez más. Entonces ya hay muchos algoritmos que han sido testeados, ¿vale? Por ejemplo, que os decía, ya hay un algoritmo que permite calcular el value at risk de una serie de valores y ya se sabe que funciona. ¿Qué ocurre? Que ahora para escalarlo industrialmente necesitamos tener qubits. Y es lo que os decía, estamos avanzando también a marchas forzadas en tener esa computación cuántica. Yo os ponía el ejemplo, en 2029 ya tenemos 200, en 2033 2000. Con 2000 qubits lógicos prácticamente puedes hacer muchísimos casos de uso muy, muy relevantes. Y entonces aquí esto es ¿Por qué es importante? Porque el que llega al primero tiene la ventaja competitiva, luego el resto se pondrá a la par, pero yo si llego primero, de momento me llevo el negocio, para que nos entendamos. Entonces eso es crucial. ¿Está maduro? Pues es que estamos hablando de que estamos ya, o sea, estamos en 2026, estamos hablando de 2029, 2030, o sea, estamos ya, y la gente se está poniendo mucho las pilas. Ahora es el momento. Lo que os decía, fijaros, el propio gobierno americano, de las noticias que nos llegan, lo que está invirtiendo en computación cuántica. Pero es que hay gobiernos, China no nos llegan casi noticias, pero la inversión en cuántica es brutal. No nos llegan casi noticias, pero lo que están invirtiendo es brutal, porque es que es muy relevante. Pero es muy relevante incluso desde la amenaza cuántica, ¿eh? Es que todos nuestros sistemas de criptografías de claves, la cuántica, si no los cambias, si no pones algoritmos cuánticos, te los pueden romper. Todos nuestros datos. De hecho, hay gente que está robando, fíjate, si está cerca, que está robando datos que a día de hoy no se pueden leer, porque no tenemos, con la esperanza de decir, bueno, pero es que a lo mejor dentro de 4 años los puedo leer. Entonces, se está teniendo, o sea, está empezando en un momento ya muy maduro, muy maduro. Y yo creo que, a ver, yo creo que la ventaja es que creo que, bueno, me sientan orgullo, o sea, yo creo que en IBM lideramos esto desde el principio. De hecho, el secretario de Estado de Ciencia de Estados Unidos era el director de Research de IBM, y que luego a nivel de España estamos liderando también bastante el mundo cuántico. O sea, el decir que uno de los ordenadores cuánticos más importantes del mundo, que hay 2, lo tenemos aquí en España, para el país, para el desarrollo de la computación cuántica del país, es súper relevante, muy, muy relevante. Por cierto, existe una red, un Quantum Network, que os podéis subir, al que se pueden subir tanto universidades, etcétera, que está abierto. Sí, y además que el sistema que es el Qiskit, que es el sistema, también es un sistema abierto y se va a utilizar. Fijaros, no sé si me enrollo mucho, pero la importancia, lo crucial también es que aprendamos, la potencia va a ser cuando combinemos las 3 tecnologías. Cuando yo al final pensar, hoy en día, pues a lo mejor para hacer para utilizar Qiskit tienes que saber programar en Qiskit. Si yo al final tengo inteligencia artificial generativa que es capaz de, que lo va a hacer, que es capaz de traducirme y hacerme ese paso de traducción, yo voy a explicar mi caso. Yo voy a explicar, mira, quiero calcular optimizar este portfolio de carteras que tiene 27 carteras con estas restricciones, etcétera. Y todo eso me lo va a hacer la inteligencia artificial, me lo va a traducir en el sistema y el computador cuántico me lo va a ejecutar. Y me va a devolver una respuesta. Y por cierto, luego si quiero, con el gobierno, etcétera, lo hago con computación clásica. Entonces, la potencia va a ser cuando encima unamos los tres pilares tecnológicos. Eso es una opinión. Por eso, aunque sé que esto es data e inteligencia artificial, ¿no? Pero pensar que en la medida que al final van a ser mundos que se van a unir. Van a ser realmente, bueno, por lo menos yo creo que están unidos.
Muchas gracias. Una pregunta ligando todo lo que has comentado, y ya que tú tienes experiencia en el sector bancario, ¿no? Has comentado que estás en BBVA. Últimamente empiezo a escuchar mucho ya en el sector el tema que acabas de comentar, ¿no? Quantum, de la parte criptográfica, y que ya están empezando, por ejemplo, en Reino Unido a sacar normativas para el 1 de enero del 28, tener los sistemas preparados para no recibir este tipo de ataques, ¿no? Entiendo que es porque ya tienen una previsión de que ya empieza a tener cierta madurez la computación cuántica, ¿no?
Correcto, totalmente cierto. O sea, las entidades financieras, pero también los gobiernos, etcétera, llevan tiempo preparándose para la amenaza cuántica. Lo primero que se ha hecho, o que han hecho todos, es estudiar su mapa de criptografía, es decir, oye, ¿qué situación tengo? ¿Por qué? Porque al final no es que ellos vayan a poner los algoritmos cuánticos. Muchos lo que van a esperar o esperan es que seamos nosotros, los propios fabricantes de tecnología, los que embebamos esos algoritmos cuánticos en nuestra tecnología. Por ejemplo, nuestros sistemas de mainframe, el Z17 creo que es el último, pues ya incorpora pues un algoritmo quantum safe, igual que incorpora un chip, fijaros, un chip de inteligencia artificial. Por eso os decía, o sea, un ordenador clásico está incorporando ya un procesador de inteligencia artificial. ¿Por qué? Porque para determinadas cargas, ¿qué mejor que hacerlo en la propia máquina. Por ejemplo, si yo estoy haciendo, imaginaros, estoy haciendo, lo comentaba antes, un sistema de fraude, ¿no?, en tiempo real. Pues yo, si ya tengo los datos transaccionales en mi mainframe, ¿para qué me los voy a llevar a una nube de ida y vuelta? Los ejecuto en el propio mainframe, porque el tiempo de respuesta es vital, porque si tú estás haciendo una transacción y tardas más de no sé cuántos milisegundos, va a haber una experiencia de usuario muy mala y necesito ejecutar. Entonces, ese tipo de cosas está embebida. Entonces, totalmente cierto. De hecho, pues entidades financieras llevan trabajando desde hace tiempo en esta situación criptográfica, en conocer cuáles son sus debilidades, y de hecho las conocen, y dónde tienen que dotarse y en muchas sí que no tienen algoritmos, porque sí que en algunos casos delegan, lógicamente, en el proveedor de tecnología el que le facilitemos, digamos, esa transición.
Gracias.
¿Alguien más en la sala? ¿No? ¿Online? No hay nadie online, ¿vale? Yo voy a cerrar un poco con una pregunta, ¿vale? O sea, es cierto, ¿no?, siguiendo un poco lo que decía mi compañera Maku, ¿no?, este es el Data and AI Day, y además nos has hablado de computación cuántica, para que no nos olvidemos de que las revoluciones siguen viniendo detrás de lo que lleva la publicidad, ¿no? Ahora mismo lo que está en publicidad es la IA, pero la computación cuántica es real. Has contado un caso de HSBC. Los que estamos a caballo entre industria y el mundo académico sabemos que hay muchos más.
Hay muchos más.
Me consta
Mucho más.
en primera persona a otros, ¿vale? ¿Cómo podría la gente empezar en este mundo, ¿no? O sea, sabemos que existe Qiskit, que es el framework que tenéis vosotros de computación cuántica. Sabemos que en vuestras plataformas tenéis cursos de training en todo esto, ¿no? Pero una cosa que me parece muy relevante es que tengamos aquí en España este ordenador cuántico, ¿no? O sea, más allá del simulador que es Qiskit, porque al final no deja de ser un simulador de software en un ordenador ordinario, ¿cómo podríamos acceder para esta infraestructura cuántica de verdad, que sabemos que es cara acceder, ¿vale?
A los ordenadores cuánticos, me cuesta responderte. A los ordenadores cuánticos, tú, Cristina, pues...
Todo el mundo tiene 10 minutos de acceso a un ordenador cuántico de IBM al mes, cualquier persona. Nada, entrando en IBM Quantum Learning, puedes entrar una vez al mes, 10 minutos. Te puedes crear una cuenta y es totalmente gratuita.
Sí.
No son simuladores.
Sí, ¿no?
Perfecto.
Sí, y además eso yo creo que además lo llevamos porque siempre podías acceder a esa simulación, esas podías acceder desde hace bastante tiempo. Nosotros ahora hacemos el propio ordenador, pero durante mucho tiempo tenemos Quantum distribuido, ¿vale? Entonces siempre ha sido un poco la tendencia de permitir ese acceso y de dejar el Qiskit abierto para que la gente también pueda utilizarlo. Evidentemente luego, claro, si tú quieres trabajar en casos de uso más de universidades, también existe la posibilidad de acuerdos de colaboración. ¿Vale? O sea, casos de eso, pues para probar ciertas potencias. Con las empresas, por ejemplo, sí que trabajamos en el de San Sebastián, pues para poder hacer ellos participar a través de un consorcio que hay que se llama Lanti para poder acceso, pero eso es a nivel más empresarial.
Bueno, pues muchas gracias, Chris, muchas gracias, Álvaro. Les damos un aplauso.
Gracias a vosotros.
Y ahora tomamos un descanso de 15 minutos y volvemos a 1:30, ¿vale? Con el segundo turno de charlas con Claudera y Dama.
Muy bien.
Okay, so we are back from the break, and we enter on a second series of talks. This second series of talks go more into the data and platform-related side, and it's impossible to speak about big data and not speak about a technological vendor such as Cloudera. So next talk is going to be Daniel Torbellino from Cloudera, and he's going to give a talk, Si el mercado acelera, tus datos deben seguirte el ritmo. So, Dani, the floor is yours.
Un aplauso para ese Dani o algo, ¿no? Me han dicho que no puedo ni bajarme ni nada, así que intentaré estar por aquí, por esta zona, pero si tenéis que acercaros y decirme algo, sin problema, admito secretos. No sé si la charla en español, en inglés, al final. A ver, ¿quién prefiere español? ¿Quién prefiere inglés? No me hagáis un empate. Así. ¿En inglés? Obviamente, nacido en España, así que el que más domino es el español. Así que, pero bueno, vamos viéndolo. So the talk is going to be about data in motion. So all the business, so I guess all the talks they were talking about the AI, more related. And as Manuel was saying, you can't have AI if you don't have data. And in the world we live in, that everything goes at the speed of light, we need that to follow. Before entering there, I want to sell you something. And maybe if you've been in one of my talks, you've already seen this trick, so please don't say anything to the person close by. Who knows what's this? You can raise your hand. Who knows what's this? Don't be shy. I'm going to know when you were born. Okay, a lot of people. For those that maybe they don't that close, this is a newspaper. This is yesterday's newspaper. And my plan is to try to sell it to you. And you can think, how can you sell a paper from yesterday? You can freak out what people are selling over there. So that little Marv, super nice with the Kinder. This is super nice, eh? I don't know if you if you know what's this here. We used to talk through those guys there, and obviously with games. The battery could last like a week, more or less. And this is my favorite. This is art, pure art. So if those guys, they can sell that, I can sell this to you. So let's do a bet. Let's try to get the maximum price. How much are you able to pay for this newspaper? I'm going to tell you the cost. It was 3 euros. Yesterday newspaper. Who's going to pay me the 3 euros that it cost? No one? How about, I don't know, 2 euros? Anyone? 2 euros? 1 euro? 1 euro. Okay, I'll take it, no doubt. Okay, now let's change a little bit the scope. Let's change the time. It is not yesterday, it is today's. And just imagine that it happened like when the electricity went down, that lockdown of electricity, that we've been like 1 day knowing nothing about the news. It was like, I guess, 6 months ago, 1 year ago. And this is today's newspaper. First time you're gonna see the news. And just imagine that has X or Instagram in it. So all the information you wanna read. How much will you pay me for this newspaper, today's newspaper? Who will pay me like the 3 euros it cost? 2 euros? Okay, so I'm getting a little bit more. Okay, the idea is that data, the value of the data, decays. It doesn't value exactly the same depending on when you get it. So it is something when a business event happens, you need to collect that data, and you need to move that data to somewhere where you can do something with that data. That time that we move, since we take the data and we use it, it is called the action time. So just imagine that you are buying a ticket to go in an airplane, or you're going to do any kind of interaction with any of the companies that you are buying services. So from the time that you do something with them till the time that they are able to act what you're doing, there is a lag. Just imagine, for example, fraud detection. Just imagine a Bizum. You are having dinner with your friends, and you start sharing the Bizum between you in order to pay the bill. And at the same time, there's another you doing the same in China. I'm sure you want Red Seas or Bizum to detect that someone is using your credit card in another part of the world at the same time as yourself, which is impossible. You can't be in China and here at the same time. But you need to detect that, and you need to act as soon as you can. That's what the data emotion, I'm going to change side. What data emotion means is trying to shift to take the action far from where the business event happened and try to get it as close as possible from what really happened. So to move this action. This is what is called data emotion, and it is close to real time. Now let's move to the next one. Same newspaper, but now it is the newspaper of December 23rd, 2026. I don't know if you know that the 22nd of December, it is the National Lottery. So in this newspaper here, I have all the winning numbers, all of them. How much are you going to pay me for this? Who is going to pay me 1,000 euros? Oh, that's better. 3,000? Will pay me like 10K? All right, now I can get more money. But obviously, I'm not a fortune teller, so I can't be sure that the data is right. What I'm using is artificial intelligence to get there. The prediction is going to be as good as the data I'm using to do the prediction. So before betting 10K to buy that newspaper, you should make sure what data you're using. Why? Because AI is getting everywhere, and you have some figures about the number of, the percentage of organization leaders that they're going to have AI in the tool set, how many they're trying to agree that it is the meaningful business value. So there's a lot of hype around AI. But AI is not perfect. You can have hallucinations. Your models, they can drift, and they stop predicting what they should predict. And you have data quality. Data quality can kill dashboard, ML, and now it's coming against GenAI. And it's happening already. This could be some fun things over here. Draw me a big hot dog. So you have a big hot dog, super funny. Or here, mix with the cheese in order to make the sauce a little bit more sticky, put some non-toxic glue. I don't know if those things like non-toxic glue exist. But it can happen also in real life with real things. For example, Air Canada had to pay the ticket from one of the travelers because the GenAI suggested a ticket for a value, and when tried to buy it, it couldn't. So you need to make sure what data is feeding your AI models. As Manuel said, I'm Daniel Torbellino, and I call myself data and AI storyteller. Actually, I'm solution engineer, pre-sales, you call it. I also teach in a business school and also in a NGO. That is very nice because there's people that is in risk of being outside of the society, and we teach them digital skills to move. And also, I'm a member of DAMA, that you're going to hear from another member of DAMA in about 30 minutes, that it is the biggest and the most renowned organization regarding data. So you'll learn a little bit more about that in a minute. All right. It's the big one, eh? I'm hitting the big one. Okay, so I'm giving another talk in the AWS Summit the 4th of June. In case you want to see another, it's not going to be newspaper, it's going to be something different. If you want to come and see, you're more than welcome. A little bit about Cloudera. So we are leaders in data. We say exabytes. For you to have an idea, it's like you get a grain of rice. If you get a grain of rice for each byte that we store, you can cover Europe till the Pyrenees. So that's the amount of data. So the only companies that they keep up with us in data, they are obviously big ones like Oracle, IBM, or the cloud providers that AWS or Azure. So we're big there. And also, we are one of the greatest places to work in Spain. So I leave it there. In case you want to learn about data, you know where to go. OK, so let's move a little bit to, I guess you're doing, I don't know exactly what it is you're studying in the master that you are concerned right now, but I think something about big data you should be learning. So what it is, and I'm going to go a little bit, move a little bit forward and backwards. So I hope that some of the teachers told you about the 3 V's of big data. And the 3 V's is not just the volume of data, the variety. Today we're going to talk about the speed of data. Because the speed of data is something that also changed the architectures. There's way more V's. There's 7, and over here there's one called viscosity, there's virality. So I don't know how many words we have with V, but you can fill all the big cloud with all the big data with that. So what it is this real time in a big data architecture? This is ours, this is Cloudera's, and we have all the injection and real time in these 2 parts. But if we move to another one that is called Stackable, it's a German company, they also have injection, they also have real time in their architecture. Another one, Axel Data, they have it over there. So it is everywhere in all the big data architectures. Now I need to come back in time. Okay, real case, where you're going to need, what are you going to need real time? For example, when you talk about AI, you need AI to respond in real time. You can't detect fraud if you want to wait 3 minutes. In 2 minutes, the bad guy gets the money and leaves. So you need to close that window in order to catch the bad guys. Everything that there is regarding real-time applications, I'm going to tell you now some of the use cases from some of our customers. But for example, it is when you have customer interactions. Just imagine that you are an air flight company, or like Emirates, or you are like Carrefour. You want to catch what your customers are doing in the moment they're doing. If they buying, I don't know, lettuce, and you have a super offer that with the lettuce it comes olive oil, you want that to happen in that very moment, but you want to personalize for that particular users. So you want to know if they have a coupon in order to have that discount available in their account. Or anything regarding IoT. So when it comes to get information from devices. Here I'm leaving some of the use cases for manufacturing, things like predictive maintenance, quality assurance, supply chain, digital twins. And you're going to see in some of the places where you need real time. You need real time for maintenance. You need to react soon enough when something is happening in a car. Now I'm going to tell you some examples of this. Or for example, supply chain in order to know if you have enough of the thing you need to use. Same if we talk about, for example, in this case, financial services, we talk a little bit about fraud detection. Now let's go a little bit faster to where we were. For example, Carrefour. Carrefour, as it's pronounced in their home country. So they use Cloudera in order to have not just they decided to put together operational data and informational data. What it means is data for the use of the daily tasks and also for the analytics. One of the use cases they're doing is the creation of coupons in real time for people that did working or they are buying directly in the store. So any kind of coupon, it is not created like a week ago and then give it to you. They do it in real time when it happens. And they have the architecture ready in order to capture whatever you're doing in their site when you're buying, and they move directly to give you that discount. Another example I disclosed a bit earlier, it is Bizum. The company that is the owner of Bizum is Redsys. It's a Spanish company, so it's a Spanish development. And it's the same thing when you pay with a credit card, that when you do a Bizum, it goes to the same place. It goes to Cloudera. And what they need to do is they need to detect fraud. They have around 200 milliseconds to process any kind of credit card transaction. And from those 200 milliseconds, there are around, no, it's a second, and they have 200 milliseconds in order to detect, to say if it is a fraud or not. And the amount of transactions, it is in the millions. We're talking about around 4,000 in a regular day, 4,000 a minute, and it jumps to 40,000 a minute when it's Black Friday. And you have 1 second per each of them. So you need to act fast. Another customer, Red Eléctrica. In Red Eléctrica, what we're doing is they need to take decisions the earliest, the better. The earlier, the better. So we are moving the part of the compute, part of the decision from the data center to where the things are happening or the signal are detected, that they are in the transport lines. So we're moving and we're trying to act the closer the better to the device and to the different places. And there, obviously, you can't get all the data in batch. You need to treat the data as it comes. This is from an event. This is, well, they even put the name. Thank you. So this guy here is the head of data and AI in a company called ITP. And you might not know ITP, but it's one of the biggest manufacturers we have in Spain. Probably you have the age to have flown more than once. You probably flew on an Airbus or on a Boeing. No matter which one, the engines, they manufacture those engines for Rolls-Royce. And they have a nice business model. It is a sharing revenue business model, which means that for them, quality is key, because they are going to get money only if the engine works. And Rolls-Royce, or the company that is going to pay for the engine, is going to pay for Airbus or Boeing just if it works. This architecture that you see here, that it is strange things here, stranger things, that they are over here, those are machines, real things that they do things to create and to manufacture the engines, and those other things here they call PLCs. At the end of the day, they are the ones that they take in the signals from those devices. They need to detect any change in the quality of the engine before it moves to the next stage. And thanks to this architecture, thanks to this real-time shift, they are saving around 2-3 million euros a year. I have plenty more like this, fraud detection with SIM use in T-Mobile, 80 million. Emirates with their how they decide the food they're gonna load for the, this is for rich people, okay, for first class. The rest we're gonna eat the garbage that it is the leftover of the rest. But for the people that they go in front, they wanna give them as much option as they can without wasting any food. So they run in real time while they loading the airplane for that very same trip. What's the people? Usually rich people, they know. They have cards, super nice, usually black, titanium, things like that. And they know exactly what they like, how they like it, and they load it. So they're using that real time. Another one here, Olafly. If you travel a lot and you travel abroad, probably you're going to use Olafly because it's going to help you have internet connection, whatever you want. It's also a Spanish company. What is the business for them is they have a contract with the different telco providers in each of the different countries, and they pay them to give you the access. What they give, it is all you can eat. So it is 5G, and you don't pay 1 giga, it is unlimited connection. But they don't give you that all the time. That is what is the business model. So what they do is they analyze in real time what is your behavior, what is you using, and then to react in as soon as possible in order to give you 5G, but only when you need 5G. But at the same time, the way they do their the billing, they get information, or they used to get information each 15 minutes. So they have those called usually micro batches that they only could analyze the data and react on data in batches of 15 minutes. They lose around 200, 300K once that they had a problem, a data quality problem, actually an observability problem, on the currency. It was dollar, but it wasn't the dollar they expected. Since it's 15 minutes, they do the billing of those two bunch of 15 minutes, and each of them, it was 100-something K. Now, they're able to do it in near real time. Instead of 15 minutes, they're able to reduce that to 1 minute, so the loss would have been like 2-3 Ks. That's the amount of money you can save with this kind of use cases. How much time do I have left? 13 or 30? 20? Okay, I can get 20. Okay, let's talk a little bit of what are the technologies that they are behind of these use cases. And then, if we have time, we're going to see like a couple of demos. So first of all, where we coming? So we're coming from a transformation on how data is handled. So we started with when the applications, they were the owners of the data, and if you wanted the data, you need to connect to the application. Then we move to the world of data lakes, that we centralize the data, and we but we create what's called the informational system, where the data is centralized. And now, where we're shifting is to have the data accessible to any system in real time or near real time using buffering. But most of the companies, they come from, let's say, the old ways. So unless you're a digital native, you come from a past where you have problems like the data needs to jump from one system to the other, that you have what it calls silos. For example, that is really, really a problem in pharmaceutical companies, where each of the phases of a drug is handled by a department, and that department doesn't share the data with other departments. And when you need to do a trace, you need to do lineage from the product that it is in the pharmacy, in the shop, from how it was produced, it is impossible. So you have what is called silos. There is lack of integration between data at rest and data in motion. What I told you, for example, about Emirates, they know who you are, or Carrefour, they know who you are, and how they're gonna give you a discount, because they know you. This data at rest, they have your profile, they know what you buy. But they need to react in real time when you are buying something. So they need to have both worlds integrated. There's also lack of edge capabilities. There is a lot of problems from companies to get the data outside the edges, like for example, it's usually called OT, so operational technology. It is what I showed you before, the machines or the trains. For example, one of our customers is taking information from the trains in order to analyze. They sell the electrical equipment to the train providers, the one that it is called to the catenary, the thing that does chink and get the electricity. Now, thanks that they have a solution that gets the data from those devices, they started to analyze how each equipment degrades differently if they are, for example, in Malaga, where it is hotter, where it is salty, the humidity is a little bit saltier, compares to León, where it is, the humidity is sweet, so it is like regular water, and it's not that hot. And they can swap the different equipment and make the life of the equipment longer, so they get more profit. And what I said about governance and security. I don't know if you are aware about the EU Act, but every single company, they need to govern the data, the pipelines of everything related to AI, if it is medium or high risk. Can you imagine that pharmaceutical company with different silos trying to do lineage end-to-end? It's very complex in the real world. So what we find usually in the customers is something like a spaghetti, in my regular pronunciation, and getting into the role spaghetti. So you find this kind of spaghetti that is super hard to maintain. It's hard to move, and it doesn't allow you to get something real time. What we're working with our customers is to move them to something that we call data in motion, so real time, and also universal data distribution, so that everyone gets the data, or every system gets the data that it needs in the time that it needs. Actually, we don't call it real time. We call it more like business time or right time. Not all the data needs to be there in the millisecond. So you need to pick what is the right data. So what it is that? So what are the components? What's the technology? One of the components, and what I'm talking here, apart from being from Cloudera, they are open source projects. So you can use them in any of your projects in the master, or you can use them in the companies that they're going to hire you, or the companies you're working for. For example, NiFi is, if we do a simul, is moving the data what it needs to be. And this guy is the one that is going to be able to connect to machines and to get the data and make it useful. Then you have Kafka. Kafka is a bus that is going to take the data and is going to allow everyone that needs data to get that data without paying the task of integration. And then you have, super nice, that little squirrel that it is Flink. Flink is going to allow you to do analytics in real time. It's going to help you to call machine learning algorithms in real time. At the same time, that is going to allow you to analyze your REST data. So you can have all the analysis from the real-time data and the REST data in the same place. So a little bit of all those components for you to have a view of what you can do with these technologies. You have, for example, NiFi. There's a component called MyNiFi that it is a teeny tiny agent that you can control from the control plane of NiFi. This, you can install it in an edge device. Edge device is the minimum amount of compute that you can have, for example, in a factory. And it's going to help you to gather the data. It talks different protocols. In factories or in the utility world, usually it's not always that you have a web interface or that you have any kind of API. Usually you talk something like OPC UA and things like that. So with that, you can deploy from a central point those flows to the different factories. You have NiFi. NiFi is another open source project that it is one of the fastest ingestion solutions in the market. One of the benchmark we did, we go to 1 billion events per second. It's hard to beat that record with any other solution. Probably you know about Spark. If you want to do really injection, this is going to do injection way better. But don't ask NiFi to do, for example, to train a model or to do a join between two tables. You're going to fry it. Use Spark or use any other technology. So each tool for what it is designed. And also, it's ready for AI. So one of the things that we were talking about, why it's important real-time or real near time in AI. Just imagine you're a telco company, and you launch a new product with, I don't know, a new television channel or new device, whatever it is, and you ship it. It's going to fail. You know that there's going to be bugs in different houses because it's not going to work. So the first one that gets it and has the bug is going to call to the telco provider in order to say, oh, what's going on? I can't see the television, whatever it is. And they're going to solve it. And probably they already have an agent that you can talk to the agent, and the agent can help you to fix it, or the person you're talking to the support center is using an agent. The first time, that agent doesn't know about this new issue. It is not in the rack or in the knowledge base. It is not there. But once it happens the first time, you have real time in your AI architecture, for example, NiFi, you can feed that rack system or that knowledge base in real time so that when the next caller has the same problem, the agent, the AI agent already knows about that issue. And you can fix it right away. So that's why it's important to have this kind of usage also for AI projects. And you don't need to know how to develop. You only need to know how to move boxes and to write. It's quite nice because you only need to tell them what you need to do, and the process is going to do it for you. Stream messaging, Kafka. The idea is how it works and what it is the problem it solves. Usually you have like different systems that if you want the data to flow from one source system and you have the fraud detection part of the security system, the real-time monitoring, and you want that information to flow, right now you need to do the spaghetti I showed you before. What Kafka helps you to do is to decouple the source from the destination. Because maybe this is an IoT system that it is getting data the millisecond, and you have here a solution that can't ingest that fast, and they need in the minutes. So you need something that holds that data in a queue in order to be consumed by whatever it's needed. And the last piece, it's Flink. Flink is going to help you to do analytics real time without using batch. And here is something that it is nice to know, that it is the concept of stateful or stateless. When something is stateless, that means that doesn't have a state. It means that each time, like in that deck of cards, you get one card, playing, for example, blackjack like here, is completely independent from the next one. Doesn't have accountability of how many cards you already have, how many people have already, maybe, I have 20, okay, no more. They don't have the concept of, like, this deck is hot. That's a stateless. When you have something stateful, you have the vision of everything that happened. If you are studying Gen AI and you learn about LLMs, that you need the content, you need that information, is something similar on the data real time. So it changes from having batch to being able to understand and to work with unbounded stream. For example, with Spark, you can also do a stream, but you can't do it in a continuous stream. You need always to do batch, and you don't have the information. If you're using these micro batches, you have this context from here to here. But if you're using something like Flink, the context is endless. So the difference between an application that they don't have that state compares to an application that they have that state, they can also act what the user did 2 minutes ago, 5 minutes ago, or 10 seconds ago. Okay, still like 5 minutes? 5 minutes, okay. Let's see quick enough a couple of demos. Fraud detection. The impact of fraud detection is about 12 billion. Is what companies are losing because they can't catch the bad guy red-handed. And it's increasing. The increase was 23%. So here's a little bit what is one of the architecture we have on one of our customers, MasterCard, in order to help them detect this fraud detection as soon as possible. It starts with capturing the data as soon as possible. We talk about a little bit this MyNiFi. Move the data and make it available to everyone, sending alerts for the data, and then move this to the guy that is going to do the analysis, that is going to call for the ML process, ML algorithm that is going to do the detection. Okay, know how long it was. Okay, so here what we're seeing is how you deploy the flows into the edges. So here you have different flows that you can send to the different places. It's a design, so it's visual design, so it's easy to use, so you don't need like a PhD in order to be able to use it. Here it's consuming the data, and it's moving the data to the cloud, where we're going to do the analysis. Let's move a little bit faster over here. That was too fast. Here, this is NiFi, that it is getting the data and is doing, like we've seen before, with the van, moving the bread to everyone that needs that data. If we move a little bit further, we're going to see how we're doing the actual calculation about the risk of fraud. Here, we're visualizing the data, what's happening in real time. So you can have that visualization there. And finally, you can have a dashboard, whatever it is. This is a demo of where fraud is happening in real time. So that's like one example of how you can put all together. Another one, for example, is in manufacturing. We're talking about how much money they could lose if they don't detect a malfunction timely enough. And we're talking about that, like the case I talk about ITP, they're talking about that 1 to millions a year. This is the architecture. It's really similar, how we move in the data, same zoo animals, with Kafka, with Kudu, different engines. And here, a little bit of the video. They say put it like ultra fast. So here what we're doing is we're deploying the real-time database. So it is not like SQL or something that you have more for operational. So once you deploy that, in this case, we're deploying it in the cloud. The next step, it is starting with the flows. So let's move it a little bit over here. Here is how you configure NiFi. It is only writing. Here you launching some queries about the data that is coming from the different PLCs, about the machines, how they're behaving. Here we're going to see what is the information, how we're going to do about the model, the prediction that we're launching on each of them. You see over here the prediction probability of each of the machines. And that's all. Thank you very much. So just a bit of recap of what we've seen today. So the idea is for you to understand that artificial intelligence obviously is where the application lays, is where we have gathering most of the hype. But if you don't give the data that is needed, probably the projects are going to fail. And the talk today was a little bit trying to get you in the world of real-time data, not just volume data, in order for you to understand a little bit about what are the difference that you're going to face in different companies that they're going to have this kind of real-time data and batch data, and also teaching you a little bit of what are the main solutions that you can find over there in order to deal with all that. And with that, I guess, Manuel, you come out over here. Yes, they told me over there, don't get down because maybe there's one question, so you stay here. Now it's time for questions.
So, thank you so much, Danny. Thank you so much, Danny. Is there any question for the audience that is present in the room? ¿Alguna pregunta en español, si os animáis? No? So, any question online? I don't see any question present online. Okay, I'm going make a question myself.
Sure.
So, you have been speaking a lot about streaming, real-time, and fast data, okay? And on the previous lectures, they were speaking about AI. The first talk was about agents and these kind of things. And it comes to my mind a news that I read from Google, like I think it's a day ago or 2 days ago, that they are transforming completely the AI, the Google search. So Google search will not exist anymore. Mm-hmm. Now it's just going to be a chat text bot where Gemini is just going to answer your queries. So it comes to my mind that this is a massive real-time thing because they need to, every time, query internet, see what is there, right? So I'm thinking about Cloudera, that is a massive platform for everything in big data. How could Cloudera and which components of Cloudera could fit into this type of solution? An AI agent that needs to be updating itself constantly.
Okay, so one of the things that we're working with some of our customers, like some Basque banks, it is to mix both the traditional algorithms in the real time and what the agents then they are able to do. So the idea is to keep all the data that you are using to ground your models, because you're not going to change a foundational model in real time. It's going to answer what it knows in that moment, and maybe you're going to do a fine-tuning each 6 months or a year. So you're going to use RAG models, and you're going to use vectoral databases, or you're going to use any kind of graph databases in order to have that data in real time. Then agents, even they using LLMs, they're using them to talk to you. But they don't using them all the time to answer your questions. They have what they call tools. I suppose that you already learned about that they are the ones that they're going to act and they're going to get the data in real time. So one of the things that some of the architecture we have is the agent is able to, for example, to connect to the fraud detection system that is real time, has what is called an MCP, so it's the way that an agent can talk to an API, and is able to answer in real time with real data. So it's not that the LLM is going to know real time, but it's like, I don't know if they still are saying that you don't need to know everything, you need to know the number of the person that knows everything. So here's the same. So the agents, they have the tool to talk to any. And the other idea is also how you feed the prompts and the information to those agents that, depending on the use case, you also need real time to feed the information that is going to be, let's say, the prompt and the context for that one. So within Cloudera, we have already customers using that mix of real time and LLMs in order to solve these demanding use cases.
Okay, so we are go with the last talk of the day, and the last speaker is Sofia Kosenko, and she's from the biggest association of data management, that is DAMA, and she's going to give a talk named DAMA's Approach to the Data and AI Landscape. So, Sofia, the floor is yours.
Thank you very much. Hello, everyone. How are you doing today? Just let me, okay, perfect. So let's get started. So just the first question. I started with exam. Who knows what DAMA, Data Management Association, is? Fernando, no. Okay, so after this session, I will ask you that question again, and you will have to answer it to me. Okay, so my name is Sofia Kosenko, and I am a secretary of DAMA Spain. Also, in my free time, I'm a data analytics and AI manager at KPMG. And I was a translator, I think so, because I started my journey, my journey in this corporate world as a translator. So, it has nothing to do with data and technology. How does it happen that I flew through this all the time, and I'm here now? Because AI is everywhere, and so is data. I don't think that I'm going to talk a lot about AI today, because I think that all previous speakers already did that, and we don't have to talk about AI because you already see it everywhere. You use it on your daily life, and it's everywhere. So, what happens to the data and AI technology landscape right now? So, what is innovation? Who can answer to me? You. No, exactly, you. Okay, but only to the problem that it's not answered, or maybe with the innovation we can improve something? Okay, yes, good. So it's something like that. So we are living in the world of innovation because we are human beings, and human beings have the nature of creating innovative stuff, because we cannot live just quiet, doing our stuff, minding our own business. We need to improve our lives and lives of other human beings all the time. And the innovation is exactly the process of creating new value by introducing novel ideas, products, services, or processes. And all that happens because we need solutions to problems, or we need to improve the stuff that we are already using on our daily life. It involves generating, developing, and implementing new solutions to address existing problems or create new opportunities. Or create new problems, because sometimes with innovation, with all the technologies that we create new problems also that we have to solve. So it's like a snowball that's starting, okay, I'm going to create AI, okay, but the fraud detection, so the fraud that is increasing, so a lot of stuff, but that's why we are humans. And So, how is the innovation different from creativity? Who can answer that? Yes? Great. Yes, I agree with that. So, innovation is basically an applied creativity. And the creativity is the ability to generate new ideas or solutions that are both original and valuable, right? This is creativity. But also, we can have conceptual ideas, thoughts, or artistic expression. So, creativity doesn't have to do something just with art. It can do something to do with technology too, because all that we have right now is created based on our creativity. How do we imagine the world, right? And the innovation is applied creativity. It involves implementing these ideas into tangible projects or solutions. Because, like, all the time we have books that describe the future. We have movies that describe the future, AI. I think that everyone knows Doraemon. And all the time we just imagine that world that we want to live in the future and how it will be. And so we apply creativity to invent it. But we apply innovation to create it and to land it into our daily life. So here is just false or true, and I want you to answer. Is innovation always about creating something entirely new? Okay. Only creative people can innovate. Innovation is risky and often fails. Yes. 6, 7. Oh, we are not Gen Z, sorry. Yes, it's often risky and it's often that's why a lot of AI projects fail. It was around 80% of AI projects that fail every year, maybe. And then innovation only happens in tech companies. Do you agree with that? And we need to wait for the perfect idea before acting. Exactly. Why? Because the inspiration, we heard a lot that we have to wait in inspiration to come and to start acting, but the reality is different, that inspiration is coming while you are working, while you are thinking about these ideas and how to implement them. So, here are the answers. Right? So, and what about the landscape? What do we think? How do we imagine when we are talking about technology, about data, about AI? So, there's a lot of classy words that we are using on our daily life. And think about that 8 years ago, I was a student at my executive MBA. And it was interesting because I was totally lost. I came from Ukraine, and I was like, oh my God, I don't know what I'm gonna do. I don't know what I wanna do. So totally lost. And I thought, good idea to start doing an MBA. So it was so cheap, it was so easy. So I decided it will be the best idea to find myself. And after my graduation, one company of data analytics contacted me, and they asked me, oh, do you want to join us? And I was like, tell me more. I'm interested to know what's your offer. And they, yeah, but one question, do you know what big data is? And I was like, no. So, yeah, I know what big data is, but I was thinking about working in finance, not technology. Because first of all, I'm a woman, and I was told a lot that women are not good to doing math or doing technology. And then I was like, but finance, it sounds pretty cool, right? And they were like, no, but we are looking for someone who knows business, and you will learn then what big data is. And that's what happened. And I had to learn a lot of these concepts. But why I'm talking about it, that 8 years ago when I was doing my executive MBA, there was no conversations at all about data. Like, it wasn't existing. And I'm not mentioning AI. It was like, oh, great, sci-fi. Super. And when I started working as data analyst at this analytical company, I was like, oh, something's missing. There is a lot of data everywhere. I have to analyze it. We have no specific tools to do this. We have to do a lot of job manually. There is Python, okay, so I have to learn it. There is R, and I have to learn it. There is data analysis, and I have to learn it. So it was a long and big process where I had to start digging into it. But the thing was that at that moment just was a boom of big data. Now, 8 years after, we are not hearing about big data because there is another world that it's sounding everywhere that it's AI. And a lot of times when I'm an assistant at some conferences, when I hear people talking about AI, it feels like AI is born out of nowhere, like we are doing it in our companies. It's offered by a lot of other companies like, oh, it's such a great thing. So, and a lot of companies just really think that AI is coming out of nowhere and it's so cool to work with and it's saving a lot of money for us so we can do layoffs. It's one of interesting things that we're hearing right now, right? In every place that we're hearing Amazon did XYZ layoffs, Meta did XYZ layoffs. And we are just guessing why it happened, because of AI maybe, or because of something else. But the thing is really more complicated than that. Because we are living in very, very difficult landscape. So look at this, for example, big data landscape. I couldn't find really big data landscape image for 2026. So if someone has, you can share it with me so I will use it in my next presentation. But this was the big data landscape in 2017, where we had a lot of boxes with a lot of different technologies. Look at here. It's not orange. Yeah, so we had analytics, application infrastructure, data transformation. What happens to all this right now? Do we still have this image, or it does disappear from everywhere because we're not talking about big data anymore and we're just focused on AI? So this image is converted into AI, because this is how, with all this application, with all this technology, we create AI. But what the most important things in all this technology? And maybe I'm saying that because I'm from data and from Dama. So data is one of the most important things here, because data is what's helping us to create this insight, to create this value that we already have in our companies. When we're talking about data, we are not talking only about technology, because it would be to talk small about data when we talk about technology, because data, not data, but in general, data management has 3 pillars. And those 3 pillars that are sustaining data are people, processes, and technology. Here, on this landscape picture, we are talking about technology. But technology is just a facilitator. It's facilitating the work. So if in this pillar, 3 pillars, 2, like processes and people, do not work well, technology more probably won't work too. So, and worse now, we have a lot of stuff everywhere, like asking this question, what will happen now? I'm gonna lose my job tomorrow. Maybe yes, maybe not, I don't know. But are you going to have the need to learn something new? Because look at that. I started as a translator. I would say like 20 years ago. But the reality that when I was 8 years old, I started dreaming about being a translator. So we can say that it was earlier that I started to be a translator, because we are what we think we are, right? And but what happened? And I was thinking about this like a few years ago that, come on, do we need translators right now? Because when I started learning translation, Google Translator was awful. It was like, oh my gosh, I'll start translating on myself, because it's so shitty, the thing that it's given me back. So I cannot work with that. What happens now? We are putting stuff into ChatGPT, we are putting stuff into Google Translator, and we have the results back, and it's quite good. We can use it a lot of times. So what is now? This is the questions that we are going to answer or not. But transforming the data and AI landscape requires a lot of stuff. It's not only about technology. We need to have intelligent enterprise. We have to have AI-driven industries. We have to follow emerging trends, use cases, and align this strategy. When we're talking about AI, we always have to think that, what do we need first to align it with a strategy? What kind of strategy? Business strategy. Because with AI, it's like a play tool that we can play, a good tool that we can play with, that we can create images, that we can create good text to post on LinkedIn, like, oh, how cool I am. But what exactly we're expecting from AI is to give us back results that really matters for our companies, for our business, and for our work. And here we're not talking about revenue only. Also, we are talking about our emotional benefits. Like, I can finish this job early and go out with my friends to take some beers, because I can do it and technology will help me. But I'm not going to stay here till 9 p.m. and tomorrow I will start at 8 a.m., right? So AI data recommendations are based on the assessment of capability and architecture. So here we have like the important point that we have to understand before working with AI. I'm not going to go, how much time do I have? 20 minutes. Okay. So all this you can see on your own. I will be happy to answer all your questions about AI data ecosystems, about everything that you have on this presentation on LinkedIn or my email. So, but just for you to see that we are not creating technology anymore. And what do I want to say with that? Because we have smartphones, we have software, we have Cloudera, right? But, so yes, we are creating technology. But what do I mean exactly? We are not creating technology, we are creating ecosystems. Because all the technology, all the processes that we are working with, they have to work together and to be interoperables. So, we are creating ecosystem now that have to have the common language, that have to work together, and that have to bring us good results. And right now, I want to talk to you about what's Dama, because all this conversation that I had about technology, AI, data landscape, what it has to do with Dama, like Data Management Association. What I told you at the beginning, that one of the central things that all that landscape and ecosystem has is data, because data is something that we are working with on our daily life. And it happened to me to call to some customers and to ask them, so tell me about your pain points with data. And they were like, I'm not working with data. And I was like, wait a minute, and that Excel that you are working with that column like salary, or that column like the percentage of X, Y, that stuff, is it data? Oh no, it's just an Excel. And they were like, no, Exactly, this data. This data that is coming from somewhere. Where this data is coming from? I don't know. It just comes into my desk every day or on email. Yeah, and when you start digging there, you just understand that people that are working with data, they have no idea about where the data is coming from, that they are not even aware that they are working with data. And this is today a huge issue that DEMA Spain or DEMA International wants to solve. So, Data Management Association is the leading organization for professionals in the field of data management. It was founded a long time ago in Los Angeles, and DAMA is now represented across the whole world and affiliated with more than 60 chapters. Spanish chapter is one of them. How did I join DAMA? I was in the sales side, in the dark side of the corporate world. And I needed to understand how data works. I needed to understand what my pitch to my customers should be. And I found DEMA, Spain, and I was like, okay, I learned about this company. I went to a few meetings, I went to a few events, and I was so amazed because a lot of professionals there was just doing this events. They were talking a lot about data, and they were sharing their experience, their real experience that they have with technology, they have with data, they have with processes on different levels, like operational, tactic, strategic level. And it was very interesting to hear that, especially because I was recently, a few years ago, coming from the executive MBA where no one was talking about data. So how it happened? What did I miss? So, and what is the mission of DEMA? Is to promote best practices in data management by empowering professionals to manage data as a key asset, thereby enhancing competitiveness, innovation, and sustainability. When we're talking about assets, we are thinking about houses, we are thinking about something that we see at the end of the fiscal year, right, that company got, but we don't think about data because, especially because data is intangible, we cannot touch it. So it's difficult to understand how to generate revenue on something that in our eyes doesn't exist. Then the vision is to be the reference point in data management in Spain, driving professionalism, innovation, and positive impact in society. And what about positive impact in society? Because we're doing data like we are not an NGO, we are not saving lives, or maybe yes, because some frauds can, and especially with ChatGPT and all the stuff that they are giving back, the recommendations of city recommendations, so it can be a bit violent. But the point here is that the good data is creating a lot of impact. Because good data is helping us to give good results to our bosses. Good data is helping us to get more money. Good data is helping us to create impact in society. But for example, by doing AI less damaging, more correct. And the value that we have is collaboration, and totally it's like this. DEMA and all the members that we have are totally collaborative. They are sharing a lot of information, experience, practices, use cases with you, because we all are in the same boat. We all want to have good data in our companies, compromise, transparency, and inclusion. And what's about the framework now? Because DAMA is not just a company that has members and we just meet and talk and have wine, but we have wine sometimes. But how do we deliver value to the market? So there is some goals and principles that we are working with, that it's roles and responsibilities, activities, tools, organization and culture, techniques and deliverables. And this is sustained by 3 pillars, that it's technology, people and process. And we have a wheel. It's like very important wheel for us because it tells us what are the areas that we work with usually. Usually not. These are the areas, but we are working on a new book, on a new version, and I think that some areas will be more longer, and other areas will be added because since the last book version was written, the technology changed a lot. Now we have a even bigger landscape around us, data and technology landscape. We have new concepts like AI, because AI doesn't appear a lot on this book. Data spaces, collaboration, so on. So, and I'll try this. Okay, it doesn't work. I have to make it over here, but I have to put my arm like there. Okay, great. So, what does it mean every area on this wheel? So, data modeling and design. So, the data has to be modeled and designed to be worked with, because we don't just have to have our data in the company like data lake, imagine data lake, and the data lake has, the lake, like the lake that is in forest, has a lot of stuff there, uncountable stuff. The same is data lake, exactly. So you're going there, and you understand nothing, because all the data is everywhere, there is no models, and it's quite difficult to understand. That's why exists Cloudera, because they know how to model build and improve the data. Then data storage and operations, we have to store the data somewhere, because if it's something that we cannot touch, we have to store it. And then we have to provide security to that data, because someone from marketing or someone from sale, they don't have to know how much is the salary of their colleague. So we have to protect our data externally and internally, because externally we have a lot of stuff that can happen to our data, because a lot of people want to steal our data. But then internally we have different profiles, we have different roles, we have different people that has or don't have to go inside the data and see what do we have. Then integration and interoperability. So we have to all the data that we have across the company, like Danny told before, there is a lot of silos all over the company. Like finance department has one data. Accountability department has another data. Then marketing has another data. A lot of data everywhere, and a lot of times this data is not connected. So exactly what I'm telling you, there is some company that they have exactly same projects going at the same time, and no one knows about it. And when you start working with those companies, and when you start digging there, like what's happening, you're like, oh, but you know that finance is implementing the same tool and is working with the same data that you are? Oh no, I'm not aware of that. So data integration and data interoperability helps us to build this technology and to have this data talking inside of your company. Then we have document content management, where we're still working with a lot of document, with a lot of content in our companies, and we have to know how to manage it. Then we have reference and master data, that is the key, most valuable data in our companies. It's like customers, customers, it's our data, master data, like providers, it's our master data. Salaries, a lot of times it's master data. But salaries, for example, it will be master data maybe for the domain of human resources, not for the domain of marketing. But it will be very valuable for marketing to know how much Maria is money making year. Then data warehousing and business intelligence, it's how do we model the data and how do we get insights and how do we get value from that data. Then metadata is just basically data about data. Because in order to understand what data exactly do we have, we need to understand what data is about. So we just describe data. And then we have data quality, that it's like a quality of our data, like exactly what it means. And then we have like business quality, business rules, and technical rules. So it depends on what do we want, but it's about how cool and how good our data is. And then data architecture is like all that landscape, all that ecosystems that I told you before. How is it built in our company? Because not all the tools are talking to each other. Not all the ecosystem works. Or it's sometimes to connect one tool with another ecosystem or one tool with another, it will be more expensive for you than connecting it to other one. So, and in the company, it's everything about revenue and how much money we can save. And we have like a Bible, the DM book, Data Management Body of Knowledge, not book, B-O-K. It's a comprehensive and overarching framework for managing data through its entire life cycle. It's very important because it's just an instruction for you about how to do stuff in your company to manage well your data. Because here we're not talking only about data governance, we're talking mostly about data management. We are helping companies to understand what is the framework and how all the areas have to work together. It's not like you have to follow the book like from the beginning till the end, because it doesn't work the same for everyone. Because first of all, in your companies, in your businesses, in your cases, you have to understand what the use cases or what is the need that I have in my company to understand better what is the solution that I can bring. But this book is bringing to you the solution, and you have to read it. It's quite big. And it provides a work breakdown structure for data management projects. And look at this. A lot of time we're saying that data management and data governance are not the projects, are the way of living of our company. It's like, I forgot the word, and but it's quite project. Why I saying that? Because we start with project. We cannot say that I'm going to invest 2 million or 1 million euros to do like to change the lifestyle of my company. It's like bullshit, right? But the thing is that we have to start by use cases. We have to start by small projects, given quick wins, in order to bring value value to our company. And basically, this is the example of UNE. It's like ISO, but Spanish. They are bringing a lot of guidance about how to do different processes, how to do data management, how to do data quality. And it's supported also with demo book, like working together, like the what and how do we do that? What do we have to improve and how we can improve it, right? And here the result is these areas that we have to touch during our project. And I didn't forget, but in the center there is data governance. I didn't mention it, but it's very important to mention, because data governance is about how to do all these areas to work together. Because when they are not working together, what we are doing exactly in our companies is creating silos in every of these areas. And I think this is my last slide. So, so there is Dhamma. As you can see, Dhamma is in the center of all this technology ecosystem and all this lifestyle that we have right now. Not as an association, but as data management practices that we have to implement in our companies in order to make it work. And as I told you, I didn't speak a lot of AI. Why? Just because AI works better with the help of Dhamma, or with the help of data management. And it's very important to understand, because we start small and go bigger. And this bigger is AI. With all the goals that we want this technology to bring us, there is the basis of this ecosystem, that it's data management, with all those areas to work with. And we are going escalating this, doing more projects, solving more use cases, working on it, and then creating more advanced technology that can help us to bring value. Thank you very much.
So thank you so much, Sofia.
Questions?
Now it's the last round of questions. So is there anyone in the room that wants to make any question to Sofia about Dama, data management in general? En español también, si os animáis.
Hablo español por si... No.
So,
yeah, I'm a writer also.
Online, is there any question?
Someone wants me to pay back that I had questions to the public. I don't know.
Okay, I'm going to be making a question.
Okay.
So there's a part of your talk where you have spoken about, okay, we have Excels. I mean, I think that everyone that has worked in the data world, in Spain at least, has suffered this part of, our data is just a whole bunch of Excels. And in order to put order to that, the central player role here is data management. Okay. Now I'm thinking about that with agents and this kind of LLMs, it's hard to govern that because like companies are trying to say and put some guardrails and say, okay, let's do this like this and that. But at the end of the day, for large corporations, the same as with the students. We tell them don't use ChatGPT, and they end up using ChatGPT or Copilot or whatever. Companies is the same. They can tell us, okay, use our LLM, but they end up doing whatever they prefer. So has Dama in this new book thought about this? Is Dama thinking about how to govern the behavior of users? Because by the end of the day, it's all about people and process, as you said, on how to handle this landscape of LLMs and tools that are around. And more than that, the prompts we put, because the prompts we put are also data.
Exactly. So, interesting question. And I'm sure that the new book of Dama that will be issued in 2 years, I think, or at the end of the next year, will improve a lot the information about all these terms, because right now the ecosystem that we have doesn't work without LLMs, doesn't work without agents, and this is right now a hot topic that we have to do it work, right? Mm-hmm. But what happens all the time in the company that you put the technology, it's wonderful technology, and you sell it perfectly. You paid a lot of money for that. Not you, but the sponsor of the project, so the person that can lose their work, right, their job. And what happened that people, one of the first things that they ask is, how can I download this data to the Excel? How can I work with that? And the thing is that, and this is already covered in the Dama book, is the thing about change management. What does it mean? That all the technology that we having in our companies can be the best technology in the world, but it won't be used if there is no good change management and communication plan in our company. And this is the issue, because the companies a lot of times they think that there is no need to do that because I already have the best technology in the market and it's so user-friendly. It was sold by the salesperson that it was the most user-friendly technology in the world. What happens that we are human beings, like I said at the beginning. And this is the big, big issue, because we are used to use something that it's well known for us. And how we can mitigate that? So doing change management. And then, about all the data, we have to make work technology, we have to make work AI agents. So the data that we have in our company should be good data, workable data, available data. And working on that in parallel when we are implementing technology, when we are reviewing processes and reviewing people, how do they work, and in parallel we are implementing change management. that in the end will help us to build this strategy around the technology when we are not going to just have that technology. We are going to use it and we are going to embed that technology into our daily working life. So I think that this is very interesting, but at the same time difficult question, because it doesn't have like just one stream that you have to follow, but in the end, it's the complex of action that you have to take and you have to take into consideration and work on them.
Thank you. And one last bit is a question for the students, okay? So we call this session like data and AI disruption, and we decided to put the name of the two things all together because AI without data doesn't work. And normally people go to the shiny fruits, that is AI, but they just forget for the ugly fruit that is the base of the tree, that is data management. So I think that makes a very good association to get in touch with all these rules of data management. How can they engage with DAMA, and if maybe they have special chapters for students or maybe discounts for students like them?
We can see it. We are always welcoming a lot of new members to our association. The membership is 90 euros per year, and for these 90 euros you will have like all bunch of the access to the events, all the discounts for courses, for trainings, and especially you will have an access to training material, and you can have a lot of networking with very good professionals like CDOs and so on. So you are welcomed. Now you know what is DAMA. As at the beginning, my first question was, what DAMA is? Who knows now what DAMA is?
Raise your hand, come on.
Okay, and if someone has any doubt about what DAMA is, you can contact me and I will be very happy to answer to all your questions and to introduce you to the community. Thank you very much.
Thank you so much, Sofia.
Muchas gracias, Sofía. Muchas gracias a todos. Justo estaba Óscar Marván comentando aquí en sala, lo comento también en micrófono para que todos tengáis la información. El próximo día 28 de mayo vamos a tener una sesión con DAMA Spain en el campus creativo de la universidad, que está justo en el centro de Madrid. Por la mañana va a haber una serie de charlas súper interesantes relacionadas con este mundo del data. Mil gracias a Fernando, a Daniel, a Sofía por contar con la universidad para este tipo de eventos que son tan interesantes para vosotros. Y luego además han tenido la deferencia de darnos un espacio a partir de las 4:30 para que podáis estar en contacto con profesionales del sector de primera línea, ¿vale? Es una forma estupenda de hacer networking, ¿vale? De contactar con profesionales del sector y de empezar a daros a conocer, porque el futuro profesional está ahí a la vuelta de la esquina de semanas que quedan. Así que, bueno, pues es una oportunidad estupenda. Y con esto yo creo que vamos a cerrar ya las jornadas. Mil gracias, Manu, por toda la preparación, la organización, etcétera. Mil gracias a la gente de Mr. Nilsson, que está realizando la retransmisión, a los compañeros de marketing que han estado organizando en bambalinas todo este evento, y a vosotros los estudiantes por asistir. Esperamos que en breve tengamos el siguiente evento que pueda ser interesante para vosotros. Muchas gracias a todos.